It is abbreviated, it's not actually abbreviated. Let me give it an abbreviation as MG. It is spell it. It is given its full form. Have you heard of this? MG. Can link it with MG. MG tools. Again, one more here. MATLAB is also from there. MG. What is G then for? Guys, mentor graphics. You not heard of mentor graphics? No. This reason you can't sell now, obviously. Who would be private wafer fabrication plant in India?
Can you repeat?
Who would be first private IC manufacturer plant in India? Tata. Whose semiconductor industry is going to get set up in Tata only. Name one government organization having wafer fabrication in India. I guess you must be aware of this. Wafer fabrication in India, one government organization. Yes, sir? I think you are correct. Can you please read out? HCL? Yes. And where it is? Yes, correct. So prize should be given to the Bharatdas also. And a big round of applause. Name one processor offered by AMD.
Ryzen.
So many answers. If Chopra sir is also there, he can also receive. If both of you have shared the answer, no problem. So we'll take a break now. They are not right. Hello. A very good morning to one and all. So I request our chief guest speaker, our today's guest of honor, Mr. Abhijit Phule sir, to kindly come on the dais, Dr. Manoj Jain sir, to kindly come on the dais, and our HOD, Dr. Pranoti Mane ma'am, to kindly come on the dais.
Yes.
Conferences are the crucibles where ideas are forged, tested, refined, and shaped the future of our world. This is a famous quote by Nelson Mandela. And with this famous quote, I, Dr. Kanchan Tiwari, extend my heartiest welcome to you all on second day of International Symposium and Conference Global Synergy 2024. Respected dignitaries on the dais and my dear students, colleagues, faculty members of the dais, welcome to the inauguration of International Conference Global Synergy 2024, a landmark event where industry and academia converge to forge powerful partnership in pursuit of excellence in education. It's an absolute pleasure and privilege to stand before you today as we embark on this remarkable journey of knowledge exchange and collaboration. The International Conference on Global Synergy 2024 represents a convergence of minds from across the globe united by a common goal, the pursuit of excellence in education. In today's fast-paced world, the boundaries between academia and industry are becoming increasingly blurred. It is no longer sufficient for these two spheres to exist in isolation. Instead, they must come together hand in hand to address the challenges and opportunities of 21st century. This conference serves as a platform for this vital collaboration. Here, academics have the opportunity to engage with industry leaders, sharing insights and expertise that can shape future of education and industry alike. Likewise, industry professionals can gain valuable knowledge from the latest research and innovations emerging from academic institutions around the world. And indeed, we all have witnessed this remarkable synergy unfold before our. I urge each and every one of you to seize this opportunity to network, to learn, and to engage. As Bill Gates has rightly said, conferences represent the collective wisdom of humanity, where ideas are exchanged and solutions are forged. Whether you are presenting groundbreaking research, attending insightful tech talks, or simply engaging in conversation with fellow attendees, your presence here today is an integral part of shaping the future education. I am glad to announce that our international conference received more than 50 papers, and some of these papers are from international level. So let us embrace the spirit of collaboration, innovation and excellence as we embark on this journey together. May this conference be a catalyst for positive change, inspiring us to push the boundaries of knowledge and to create a brighter future for generations to come. I am extremely honored to introduce to you all today our today's chief guest, Mr. Abhijit Mule. With over 26 years of experience as at the Automotive Research Association of India, ARAI, he has served as Deputy Director in the Automotive Electronics and E-Mobility Group. His responsibilities include overseeing the Center of Excellence for E-Mobility at ARAI HTC Chakan, Pune, focusing on development, validation and certification of electric and hybrid vehicles and their components. He is an expert in lithium-ion battery characterization, performance testing and certification standards such as GTR, ECE, R100, AIS and whatnot. Additionally, he is leading the design and establishment of an advanced battery lab to meet new regulatory requirements with an expected completion by September 2024. Throughout his tenure, he has presented numerous technical papers and filed multiple patents in electromagnetic compatibility and EV charging. Heartiest welcome to you, sir. I request our HOD, Dr. P.P. Mane ma'am, to kindly felicitate Abhijit Mule sir by presenting a memento as a token of appreciation and love. Thank you so much, ma'am. It gives me immense pleasure to introduce to you all our next expert, Dr. Manoj Jain. With over 25 years of international experience spanning across Dubai, Sharjah, Saudi Arabia, the United States of America, and Canada, he is a seasoned professional in the fields of manufacturing, operations management, and automation. Holding a BE in electronics and industrial electronics and an MBA in operation management and a PhD in management, he brings a wealth of knowledge and expertise to his roles. Currently serving as Director of Infinite Global Research Conference Private Limited, Pune, India, Canada chapter, he has also been recognized as a keynote speaker, guest of honor, and chief guest at numerous national and international conferences. His contribution to the field have earned him accolades such as Presenter Award at the AP18 Thailand Conference and the Best Table Topic Speaker at Toastmasters International. His professional journey encompasses diverse industries including electronics, computers, automotive, medical products, signage, and display, advertising, and publicity. He specializes in areas such as project management, programmable logic controllers, and enterprise resource planning softwares such as SAP, Mantra USA, and Keyed USA. Known for his passion and expertise in manufacturing, operation management, automation, and ERP, he has been invited as session chair and examiner in business management and engineering tracks. His continues to drive him forward as a leader in his field. So I request once again Dr. Pranati ma'am to kindly felicitate Dr. Manoj Jain with a moment as a token of love and appreciation. Thank you, ma'am. Now I request our today's chief guest, Mr. Abhijit, to kindly take over the session and please enlighten the audience. I request Manoj sir to kindly be on the of the deck.
Hello, good morning everyone. And first of all, I would like to thank the organizer for providing this opportunity. It is always a pleasure to come back to these kind of events and interact with students. And it is more important for me because I could see now there's a possibility of interacting with students and teachers simultaneously. So, and thanks, madam, for nice introduction. So I was thinking what topic I should discuss. It is a brief presentation. I will not take more than 20-25 minutes. And as you know, EV electric vehicle is, and everybody is talking about electric vehicles mobility. But I thought that electric vehicle in general, in many aspects. Let us focus on one specific aspect of electric vehicle. And you know that success of electric vehicle is impossible without having a good charging infrastructure everywhere. It is an essential part of for the success of electric vehicle. So I selected this topic, but before focusing on charging infrastructure, I have a story. What is that story? I am part of ARAI, and last 5 to 6 years, initially we have seen the technologies directly from China. For example, if I have to certify lithium-ion battery, I used to receive box directly from China, somebody in India trying to build a electric scooter and trying to source battery from China. And that was a situation where there were many surprises. There is a big change in last 5 years, mostly after COVID. There is a lot of design development related to this technology in India, and we are happy in assisting industry for all this design and development. So, I have witnessed that there is really a change in the approach towards new technology like electric vehicle, and you guys from the colleges have an excellent opportunity. It's not only electric vehicle, but there are many upcoming technologies. The main trigger, normally I think that May 2017 there was a detailed by NITI Aayog, where they have done a real calculation that if we go for shared electric and connected mobility, what is the achievement? By 2030, the estimation is almost 3.9 lakhs crore of rupees, approximately 60 billion USD that we are saving when we are focusing on shared electric and connected mobility. By NITI Aayog, and a lot of people in the industry consider this as a real trigger of motivating everybody to focus on electric vehicle. I will also explain why this calculation, how they have calculated the energy demand, 37% of the carbon emission saving, all by 2030. And why I am showing this slide, because this is a very old report. We were checking in 2023. Achieve these figures, but it is not that we are just estimating something, but we are on track from 2017 to 2023. 6-7 years are really important to achieve this 3.9 lakhs crore rupees of saving in India by focusing on shared electric and connected mobility. Okay, so what are the driving forces? We are, as you know, we are party to Paris Climate Change Agreement. There are a lot of commitments in India. We have a lot of commitment towards the international association. Then in India we have specific problems related to ambient air quality. You are in Jharkhand, and you can see because of a lot of industry, the ambient air is already worst in Jharkhand as compared to the Pune city. But there are cities like Delhi, Bangalore, where ambient air quality is really a concern. Okay, that these are main two driving forces why government was also keen in focusing on electric vehicles. But import of oil, when it comes to finance, this is the most important driving force that we have to somehow handle this expenses related to import of oil. When it comes to ICE vehicle, internal combustion engine vehicle, as you know, we have to use petrol or diesel, and there's a lot of import of oil which is happening every day when we are consuming, and this factor is a significant factor in our financial management. The last point is thrust on solar power generation and storage. We are fortunate in India, we have ample amount of solar energy. It is the innovation which is required to utilize all the solar energy, and one of the innovation I can give an example of swappable battery. That means if I am driving a scooter but my batteries can be swapped. There is a swapping station which has got one of the input source as solar. Then we are directly using that energy in the battery which is utilized in the mobility. And solar is a big but friends, you might have seen a lot of discussion on well to wheel. You know, still many people are not convinced. They say, okay, I don't know why government is focusing, but I still feel that there are, if you calculate the total emission, anyway, the electricity is getting. There are a lot of discussions related to lithium at this moment, the overall cost involved in manufacturing those lithium-ion battery. But many times we forget to discuss one point, which is motor. Okay. In case of electric vehicle, whatever motors we are using, MSM or BLDC motor, all these motors are efficient more than 96%. Okay. That means whatever energy you have, almost 96% of that energy can be utilized for attractive force. Whereas there is absolutely no engine in this world which is efficient than 35 to 37%. Even if it is Mercedes, Porsche or any extraordinary diesel engine, petrol engine, nothing can be efficient more than 36 to 37% even if we go for hydrogen ICE. This is a big factor. And when you say 35%, what is the remaining wastage? It is like temperature, pollution that we do when we are driving ICE vehicle. So this is one plus point where now we feel that there is no looking back. In India, worldwide also, people will cell or sodium ion battery. I'm just changing the battery configuration or RESS configuration, but there for the tractive effort there will be a motor, electric motor. Design development is happening in the which is really important. So important for government of India. That's why they have given a lot of motivation. There were many subsidies to promote electric vehicles. There is another point when we used to attend government meetings, when the ministers, for the last 75 years, engine manufacturing was the forte of India. There were only 5 to 6 companies, big companies, manufacture engine because this is not possible for a startup to manufacture. It is a big subject. But when they promoted electric, the market is really opened up. There are a lot of startups. You can imagine in 2013, I have done the first test on Ather scooter for their suspension. And there were only 3-4 people passed out from IIT Madras. But now you can imagine they are selling 15,000 vehicles every month. So this is possible only in case of electric vehicle, but there are a lot of where it is an engine manufacturing. This subject can be handled only by big players. I cannot have a shade in Jharkhand and start manufacturing engine. That is impossible. So this subject of mobility was limited to few players, but this e-mobility has really opened up the market. There is an ample opportunity for startups. So I keep one diary. Every year, whenever any startup I get opportunity to meet these people, I make a note that what is this startup, what is their objective, what exactly they want to do. There is a tremendous change that until 2018, every student was design a bike, electric bike. I want to design an electric car. That was the approach that they were focusing on the total product. Now there is a big shift that a lot of startups are saying, yes, I want to manufacture the charger control embedded board. Okay, their approach is a system approach now. They have understood that in automotive industry, it's impossible for everybody to be. But in the same country, there is also Tata Mahindra and Bosch Continental, which are tier 1 suppliers. This realization is very important for the student. You can be a supplier, battery management system supplier, and can be a very successful entrepreneur, but not everybody can manufacture the vehicle. So understanding in the young generation is very important, and I could see that change, that now a lot of startups are focusing on systems and they are really successful. They are trying to become tier 1 supplier, tier 2 supplier to a vehicle manufacturer. Okay, so coming back to the main topic, charging. Okay, I drive electric car for last 1 year. My wife drives electric, have some experience. You have to understand that electric vehicle charging does match refueling habits of ICE vehicle. That means I used to get petrol from petrol pump when I drive petrol car, and once in a week this refueling was. For electric vehicle, there's slight change. Okay, electric vehicle owners mostly frequently the vehicle at home or at works relying on slow chargers. Okay, this is very important. 90% of the time I am completely relying on my home charging, which is a overnight charging, and obviously it is a slow charging. It is once in a while when I go out of Pune, then I may have to look for fast chargers along the highways, but mostly people are very comfortable with home charging. And this was the reason why swappable battery for scooters were not very successful in Taiwan, because they were saying, the swapping is okay, but I also want a plug to do home charging because I am very comfortable with home charging. In night time, if I have a parking and a single phase connection, that is the best way of charging your electric vehicle. Okay. The next most frequent charging choice is publicly available slow charger, followed by chargers located in commercial facilities. Anyway, my electric scooter will be parked, and if possible, if it is a EV slot, I can also charge. Slow charging 3 hours is a good option. And mostly people at shopping, at offices. When I go to office for 8-9 hours, my car is standing there. So I can do slow charging. But fast charging is, even though fast charging is not frequently used, it is very important, because that is going to create the comfort of the electric vehicle drivers, and they will be able to. That on at Smilestone there is a charging station, or after Smilestone there is a charging station, or if I want to travel to Kolhapur, I know at Karad, before Karad also there are a couple of charging stations. So this kind of availability of DC fast charger is very important. They are not frequently used by many people, and that's why at ARI, at automotive industry, we are doing a lot of research on DC fast charging because it is creating the comfort. Okay, so these are just points when it comes to charging, and that's why people, for example, if you see worldwide public charging infrastructure, you will find 10 AC slow charger and then 3 AC fast charger. That is the ratio. AC charger, those are less costly products, and few DC chargers. This combination is also fine. So if you see many government tenders, they are buying more AC charger, putting it at offices, government offices, theatre, shop, and few DC chargers which are required for highways mainly, to ensure that there is no range anxiety. This is very simple. You can see a car. When I am talking about AC charger, there is a converter on board. That means there is a AC to DC converter on board. We call it as onboard charger. And if I connect single phase AC or 3-phase AC, the car gets charged, the output of converter is obviously DC. Okay, but if you use DC charger, then you are bypassing this converter. That means if I am driving Nexon, Tata Nexon, my DC charger is directly providing 360 volt DC, and I am bypassing onboard charger, but I can directly charge my DC battery. That is a DC fast charger, and there is there is a possibility of increasing charging current if your battery technology, lithium-ion battery technology, also supports that kind of charging current. Okay, so this diagram just showing what is AC charging and DC charging. On the right hand side, you can see a panel which is DC fast charger, which is directly connected to battery, but AC plug is connected to onboard converter, DC converter, which you carry. Suppose that is 35 kg. All the time your car is carrying that converter, like your laptop adapter. Okay, so this is AC and DC. In India, if you remember Nokia mobile era, used to have small pin charger, large pin charger. There were a lot of issues related to combating. But at one stage, we have come out of that problem because we can have only 2-3 options. Type C hai kya? And there is one more plug, and there is iPhone. So we have from say 15 to 16 options. Now we have come down to 3 options, and we have good comfort because wherever you find this suitable charge. In India, AC charging, the Ministry of Power has decided that we should use Type 2 charger. Okay, also popular in Europe, and which has got 2 options like single phase and 3 phase. So if I buy Nexon today, I can connect single phase Type 2 charger. That means grid supply is connected to vehicle for the first time in the history. It was never connected to petrol or diesel engines, but we are connecting grid supply, and that is single phase. But if you buy BMW, for example, BMW has got a 3-phase Type 2 charger. Okay, so 3-phase AC is connected to car, and then the converter uses that energy to produce DC inside the car for charging. So Type 2 is our selection, and we will see now because of the standardization on the vehicle side, all future vehicles will have this option. There won't be any problem. So you'll find chargers also, you'll find vehicles also with same kind of connector. It's very interesting that when you connect, even though it is a simple AC charging, there is a communication between charger replies, yes, my capacity is 16 ampere, and then there is a PWM. Vehicle and charger. On DC side, we have shortlisted CCS. So you can see there is a Type 2 on the top. If you see this diagram, this is a vehicle side connector, but there are positive and negative additional 2 pins for the DC charging. And this is very interesting that for the power line communication. Okay. We have been using CAN, we have been using a lot of other, but the power line was very rare because it has come from industrial electronics. So in DC charging, we are doing power line communication. That is a very detailed handshake of parameters between car and charger. They talk to each other, they synchronize, and then the charging happens. Okay, during charging also there is a good monitoring because we have to take care of safety. If there is a over temperature situation, over current situation, DC fast charging. So India has decided that all M and N category vehicles, that means car and above, we are not talking about 2 and 3 wheeler. This is car, buses, trucks. We will use CCS for DC charging, Type 2 for AC charging. Okay. Now this slide, I just want you to focus on last 2 points. What has happened is like in North America charging standard, it is originally a Tesla connector because Tesla, you know that Tesla cars are very much popular in America. So formerly known as Tesla charging connector, but now a lot of US companies like Ford, GM, everybody has decided that they will also align their connector with Tesla connector, and that will become NACS or North American Charging Standard. Also, there is some work going on between Japan and China. So, Chaoji we call it as. They are developing a new connector and a Japanese and Chinese people together, but this will take some more time to have this technology in reality. So, to show you what is happening on the charging connector side. Ministry of Power, they have given a notification what kind of charging you should have. For the first time in India, now I can sell electricity. Earlier it was not legally allowed, but there is now a proper notification that I am eligible to sell electricity. So I can set up a charging station, I can give service to electric vehicle manufacturer. If they consume 2 kilowatt hour energy, I can charge for 2 kilowatt hour, I can add some service charges, charging station. So government is looking at this opportunity. Like if you remember in the 90s, there were a lot of STD booths, and government was having a lot of scheme for physically challenged people to run those kind of centers. So now you will see a lot of such centers, charging points, where you can go and charge your scooter, your car, your bus. So this is really coming up. I will spend 30 seconds on interoperability. So if you come to AII, we have developed our own simulator. This will act like an electric vehicle when I am certifying charger, for example. Exercise all the communication between electric vehicle and charger. Act like a charger, for example. Or I can put that simulator in such a way that I am using man in middle and I am checking what communication is happening between car and the charger. These kind of simulators are very important because it should not happen that you are going to Mumbai, but some charging stations are suitable only for Mahindra but not for Tata, for example. That should not happen. And that's why there's a lot of work, there are a lot of software engineering people in their brain in creating different test cases, scenarios, and day by day they are ensuring that there is an interoperability. Even my car will get charged at Germany charging station. That kind of interoperability is required. Problems, but slowly now I think there is a good maturity in the system from charging side to take care of interoperability. So at ARAI, typically when we test and certify these charging stations, there are 4 important activities we do. We perform 5 to 6 tests to ensure that there is a electrical safety. Shock nahi baithna chahiye. Okay. There is a for a lot of high voltage and other stuff. So we perform those 5 to 6 tests related to electrical safety. Then we are testing the charger for environmental condition. Like we have, suppose you are installing this in Rajasthan, the outdoor temperature is very high. So European standard we are saying only 45, but we have modified Indian standard up to 55. Even though there is small derating of the power electronics, it is allowed, but it has to function properly because it is an outdoor application. Then we perform EMI/EMC. It is very important that electromagnetic compatibility is ensured. Very close to airport and my charger is not working there, I cannot drive. All those situations we have to avoid by ensuring electromagnetic compatibility. And the last thing which is very important is interoperability. Not just with electric vehicle but also with server, because every charger speaks same language where it is sending data back to the server. So like when we will have thousands of chargers, we require some servers to control all the charges. So that backend communication interoperability. We call it as OCPP backend communication protocol. This is simulator. So generally, these are all charges developed here. So when I am certifying, I am the inspector. So I can say, okay, pass, fail, meeting, not meeting, but generally in ARI we have a approach that first we should understand the subject thoroughly. So initially we thought of developing those charges ourselves, where everything was indigenized. Software, we have we have sourced power electronics from one company from Pune. So there is no dependency on Europe or China. First thing that we have done. Then we were in a better position to certify and handhold industry, support them for testing and certification. So we developed many such models. That time, except for charging gun, everything was localized. But I am happy that in last 1 year, 5 to 6 companies now they started manufacturing even the charging gun in India. So there's a company called Elcom in Haryana. They are manufacturing all these guns in India. So now everything is Indian. It is possible. And a lot of credit goes to government because they provide more subsidy when you ensure that you have localized most of the product when you are manufacturing any product. So a lot of credit goes to government schemes, not only for charger but also for the electric vehicles. Okay. Last two slides. People know us for testing and certification, but in Jharkhand, when I sit at Center of Excellence, almost 55% of our revenue is non-certification. That means we assist in design development. So we do component sizing. We have helped many startups to do component sizing, control system development, vehicle calibration, system integration. And these are few glimpses of our COE green mobility, where suspension up to battery motor, for every component, whatever tool chain, expertise, competency required for design, development and certification of electric vehicle, everything is available under one roof at COE Green Mobility at HTC Jharkhand. Okay. So that's all I have, but if you have any questions, maybe at the end of the session, we can discuss, or offline also I can answer all your questions. Thank you very much for patient listening. Thank you.
Thank you so much, sir. Thank you for sharing wonderful insights regarding EV charging systems, particularly slow chargers, fast chargers, and giving us an overview about how AR, AI is growing up. So once again, thank you so much. I have the privilege to introduce our keynote speaker of today's session, who is stalwart in the field of automotive, Mr. Vishwas Vaidya sir. He is senior consultant, ex-Tata Motors, ex-Minda. He is having 33 plus years of experience in R&D and EV. He is postgraduate alumni of IIT Delhi and graduate alumni of COE. So now I give the responsibility of session to sir. Kindly preside over the session.
How many of you know what is system engineering? Anyway, good morning all, and actually very happy to continue on the second day. This kind of rare opportunity, both days, shoulders with academics, industry, such a diverse and rich audience. The topic actually selected based on the gaps I have noticed both in industry and academics. So how many of you know what is system engineering? Particularly students. I can see many students. Have you heard system engineering. Yes. What is system engineering?
So it's like it deals with the various types of systems in any of the some biggest part or some anything of the some controls. So like wherever think of the control systems, system design engineering plays a major role during the whole process parameters.
Okay. You are on the right track. Like you say, human body. Actually, this is complete system of so many parts. You may have maybe facing problem with eyes, but actually the problem may be diabetes. Somebody is raising hand. So automotive, system engineering actually plays a part when across the area, students as well as development team members when there is a need to plug the gap. People generally work in islands and whatever. Now we start with those who were with yesterday. Bouncer. Some of you might have attended my lecture at college. They did not answer this. What is the cleaner mode of city? See, if you see the left side, this is New York City, maybe 150 years ago. Yes. And then you have automobile. Which one is the cleaner mode of transport? This is where system engineering comes in. Which one? Horse is cleaner. Any other answer? Not you others. Any other answer? Is a horse autonomous vehicle? It can travel on its own. Is a human being autonomous vehicle? No. You can travel on your own. Why? But anyway, what is the exhaust of horse? You see, 1 square kilometer, some 1,000 horses are there. They are moving all around, they have to eat a lot. What will be their exhaust? Waste. So what will be the stink, amount of stink? So that was the question. And that is what is system engineering. So that was a burning problem. And that is how the cleaner mode, which is your automobile. And whenever there is intelligence is like a double-edged weapon. Like horse, earlier horses are definitely intelligent. And compared to even earlier vehicles. And if horse goes wide, it doesn't obey. You will not be able to stop the horse, correct? Horse will just even unleash itself, or it can obey its own whims and sits, and then you have it. So that is what is this is the overview. Then the DNA system using DNA. And that is what is the Toyota problem. Yesterday, so I don't know, not everybody was there yesterday. Intelligent, like a horse, or put a brain. That brain can go wide. And when you are standing on the brake, person was standing on the brake, vehicle now refusing to stop. Okay, and they died. The famous Toyota problem. And actually, I take students, team members, that see medical students or legal students, they study a lot of case studies, famous case studies. But we in engineering, we don't do that. They are actually famous case studies, but even the seasoned automotive audience will this case. This is the Toyota electronic throttle. And it is not just the question of if you have both the inputs on. See, those who are not there, there's a problem that the Lexus, Toyota Lexus. When the people hire cars in USA, you go to airport and you reach airport for vacation, business. You don't hire a taxi, you hire a car. They hire Lexus, and unfortunately, it was refusing to stop 100 miles per hour, even if you are standing on the brake. And that is how he phoned 911, giving video that I am standing on the brake, vehicle is refusing to stop, but this video is for to save others. We are anyway going to do. Then he says, wait, and he perished. The family members. And this is the term, this OEM they try to wriggle away saying that this is a carpet problem, this problem. But I tell my embedded students, everything is in open domain. What are the mistakes, which possible mistakes which were made? They ripped apart the last register of hardware, they ripped apart the last bit, last RTOS segments. And many lacunas were noticed, and that is a really case study for all embedded people. So it is not just that both the, suppose it is not as easy that both accelerator and this is pressed you on the brake and road. It is not as easy as that. How in the real time, what bug, which is not always occurring, flip that bit of your accelerator. But anyway, that was there. Why it could happen? Because writing software, it doesn't know what a vehicle is. That is the unfortunate reality. Even the global don't know what a vehicle is. They are happy to answer the processor work, the kind of quiz questions they have, that they are happy to answer. But if you are working on what a vehicle is, you never know, don't know. What is the repercussion of every decision you are taking to the person who is paying money for your vehicle? They don't know. That is what. And this is not Tata Mahindra. This is Toyota, but I find since we are relatively poor country, we don't afford luxury. That one person doing only a small job. That works in our favor. We know many things. So our people are likely to know much more. But this is the one incidence. Another one. How many of you have heard of anyway, the one more case, the ignition switch sliding. How many of you have heard of Mary Bar? How many of you are member of SWE? Society of Women Engineers. Please be, if you are not. Mary Barra is CEO of General Motors. Around 2006, she became the CEO of General Motors, and people said how fortunate she is, how lucky she is, because the big three in the world were GM, Chrysler, Ford, those days. Now they are no longer big three. Being a CEO in a male-dominated fashion, she must be very fortunate. But within the week, people started saying, no, she is not very fortunate because the ignition switch scatter. See, throttle also technology is should be well maintained, but doesn't get run throttle. But ignition is a kind of technology which has been there over decades, almost a century. So, ignition switch of one of the General Motor models, they say if a user is dangling that ignition switch with a heavier keyring and you are driving, it would go on its own from ignition, from the ignition to accessory position. That is ignition off, but between accessory. If that happens, the engine will stop midway, and if that happens, but the air that senses ignition is no longer on, it fails to deploy. Same as your Toyota, and he had to answer. Last week you become a CEO of world's biggest company, and with a double-edged paper, next week you have to answer. And in heart of our heart, you say, why should I answer? I am not responsible, but you cannot say. And ignition, you see, now people can say, suppose you are a tester. People, the test till failure. What a tester should do, he has to test cases so that how can make this fail. Tested in both cases. Our system designers in both cases failed to that if my ignition switch goes into other position, but vehicle is moving. That can be a case. And in that case, my ECU, airbag control unit, can definitely to double check is really my vehicle is off, my engine is off. How will it double check? We have any sensor, vehicle speed sensor, engine speed sensor, first comes down. If you do that, definitely you have second thoughts. And airbag deployment is a very tricky issue. If you deploy when not required, still you will kill the person. Actually, one of the very easy cyber hack to kill a person is to make the airbag deployed when you are driving. So the person is killed. But anyway, so another. So what is these two sides? These are not Tata miners. I am from Tata. Of course, I work in the motor also. So it is not just that you have advanced tools. You have simulations. You have software in the loop. There's a big jargon. But you don't know what is the vehicle, what is the use of that hardware. Do you really need high-end computers? Do you really need high-end test automation to check if somebody is standing on the brake and vehicle mark? Do you need a very high-end infrastructure to see if vehicle is running on my ignition switch goes, what will happen to the logic of my chip? You don't need. You need plain common sense. You need a bigger view, system engineering. That is why, in my opinion, the system engineering mindset is much more precious than all your tools put together. Don't have that mindset, you will not be knowing how to use those tools. Battery. You see so many battery burning. I generally tell people, electric vehicle is a very good college project. We have gone through, even in my earlier companies, we have gone through this. Why it is a very good college project? On day one, how many of you have driven electric vehicle? I don't know, but it's a pleasure to drive. On day one, when you are demonstrating to your examiner, everybody is very happy because moment you press, zoom it goes, and that is what a vehicle should do. Unlike IC engine. IC engine struggles to start. The torque speed curve is different. Whereas if you just press your pedal, zoom it goes and everybody is happy, clap, or there are interviews, YouTube, and the startup has started an EV. But few months down the line, you find batteries are giving up. Batteries are burning. Batteries need to be changed. Why? Because actually, battery, you need all your physics, chemistry, mathematics. Every single kilowatt hour which is entering the battery and which is exiting the battery has to. Don't do that. You are aging your battery, you are propelling its future towards burning. That is what the startup do. They feel, they even toy manufacturers have this EV. Just put everything together, it works. It works today. So battery, actually you have to do a lot of engineering. You have to have algorithm infrastructure there, that how my battery is aging, how can I restrict amount of kilowatt hour coming out, going inside in the given situation, in given temperature, in given age of the battery. Like you go to a orthopedic surgeon, say what is your bone age? You say your calendar age maybe 20 years, but your bone age is 30. You are aging fast. That is what is battery. You have purchased battery only, vehicle only last year, but its age is 3 years. That is what happens. And that is where slowly it degrades, it heats up, and you have battery burning issue. I tell many of my, a lot of my audiences are working professionals. I tell them battery is a kind of or a new battery, new vehicle is kind of newly joining team member, very enthusiastic, trying to impress everybody, trying to deliver. And doing that, if you shout at him or her, there is a hurt. That on that day, you may not protest, may not do everything, but that hurt goes on festering. And in few months, when you want him or her most, he delivers the resignation. That is what battery does. You abuse the battery without understanding. You have not studied the battery specs, you do not understand what is the carbon filter, you don't know how it behaves, how electrochemistry behaves, and you just put everything together. You want driving pleasure, so zoom you press your pedal. Ohm's law will give you infinite current. Theory will give you, electromechanical conversion theory will give you infinite convert your vehicle. But there is a hidden spy inside in the form of battery, which is waiting to burn everything. So this is again another example of system engineering. Like you need to connect the dots and see a bigger picture of what is happening. During the turn of the century, turn of the last century, which vehicles were more popular, electric or IC engine? Any idea? Just at the time when the Henry Ford Model T, just before that, which one? Electric or IC engine? Any other answer? Answer is electric. Answer is electric. This is your again system thinking. Why? If you are an engineer who is not biased with IC engine and others, and you are asked to deliver a solution which will take you from point A to point B. How was engineer system work? Okay, I need a solution. My powertrain, power station will be such that with minimum effort it should start. That is very electric. You press a button, your fan starts. You don't have to kick and you don't have to put the muscle for whatever and start it. So this is the first time. The first use case is starting. People that they itself will go to electric. Then you say another characteristic I want is a high torque, high starting torque. So which propulsion mechanism will deliver high starting again electric? This is how the automotive industry actually started with electric vehicles. An IC engine vehicle did not have a battery also at that time. And starting was through muscle power, proving fatal. Starting was proving fatal. Like you had to use a muscle power to pull a car. When the engine starts, your muscle senses that engine is overpowering your muscle and you retard the lever, retard the firing angle to tame it. It has to be very carefully, accurately and in real time has to be managed. Otherwise, escape your grip and it will hit you, your jaw, your body. Serious injury you will experience. There will be fatalities. So rather than going from point A to point B, it is taking you from point A to point Z, heavens. And that is what happened. That Chevrolet, one of the Chevrolet vehicle driven by a lady, it stalled on the flyover. And Chevrolet engineer was passing by. He said, "It is my company vehicle, let me help her." A lot of muscle power was needed. And people who look around, those who are not able to manage, so she was looking for help. He said, engine started, there was an error in synchronizing. It escaped his grip, it hit his jaw, there was a fatality. His boss at Chevrolet, he conducted a meeting that I have been telling you electric start. People are doing. People who are trying to have electric start, nobody has come up. So many months have gone. You have not been able to deliver it, pulled up all the electrical engineers. They said, "Sir, these are my calculations." After calculations, my motor size is coming as large as engine. Where will I keep it? And if I keep it, I will remove my engine, it becomes electric vehicle. That is our problem. Okay? So that time in America, there was an innovative engineer called catering. Even now the catering institute of technology is there in USA, Michigan. But I asked the deeply automotive audience, have you heard of catering? They said, we have. So catering was an innovative engineer. He had given nation electric cash register, motorized electric cash register, like in a retail shop. The cash register, you put a cash, you turn your back, somebody will. So instead, as a motor, you press a button, it goes and comes. So he said, let us call him. He had many innovations, both automotive, non-automotive, his credit. We'll call him. The electrical engineer said, okay, we are not able to solve. Let us see whether he can solve. They asked him, can you solve this problem? He said, I already have a solution. What? He said, the same small motor which was driving your small driver can drive your engine. Okay, let us try. It did that. It did that. Engine started beautifully. Any answer? Any? I am not sure any electrical person is here. Any guesses why did it start? But people who are coming up with a huge motor as the answer, here a small motor was able to do it. Because, see, what is system engineering? In system engineering, you must know how a large component works and connect the dot to the bigger picture. How does a wire work? A wire, electric wire carrying a rated at say 10 ampere, if I pass 100 amperes to it, what will happen? Wire is rated 10 ampere, I pass 100 ampere. Copper doesn't melt. And if there is air all around, nothing will happen to the wire. The insulation may get damaged, but that is after a time. There is a thermal time constant. That is what the motor is. Motor is all about windings. So a motor rated 1 kilowatt can beautifully deliver 20 kilowatt for more than 3 seconds, 3-4 seconds out of that. This is same as person who walks on the coal. Because there is a thermal time constant. So that is how he goes on walking till that heat harms his body. So that is what catering used. The people who were doing calculations, they were forgetting the fact that we did not take into account in 3 seconds. You can use a small motor. And very recently I used this idea. When I was asked to help out the Pune Gold Course, they wanted to have an autonomous gold cart. The company who was doing it, they did not have any EV system expert. They called me and they said that the steering is something we have to focus because all other things anyway can run. There also have to make architectural modifications. So they say our steering motor, they are coming up such that that motor I am not able to hit. I immediately remember catering. So give me your calculations. How would you size the motor or steering? It has got how much to rotate. So what you do is you go 2 pi nt speed into torque. So what is the speed? They say we will rotate the steering wheel at the maximum possible speed. And the torque is the muscle power. You can measure it. 2 pi nt coming very huge. So I told them the mistakes here. First thing is you are not in a traffic. That is what another system engineering. You see the use cases. You are not in a traffic. You can afford to reduce the velocity of steering drastically. It can slowly rotate. So again got reduced. And more than 3 seconds it is not going to rotate. 3-4 seconds. So your 2 pi nt 3 second rating you have to say what you are referring. Data sheet is a continuous rating and I was able to give them the small motor. So there is a feeling of deja vu in my mind that I teach apart from consulting, I am also in teaching. So this is the how the motor designer century ago making mistake. The same people because they don't read, they don't study history of technology. They are not. That is what is system engineering anyway. And so this is the, I will not go through, this is a very huge presentation what is system engineering. I will only take 1 or 2 more cases, particularly my OEM days. We had a sedan vehicle Indigo, which was really doing very, very well. First time, exceptional in our track record. After 4 or 5 years, and that is like Meribara. I was moved as a department head. Meribara was CEO, but okay, I was moved as a department head of in-house captive tier 1 department. We in Tata, we had captive tier 1 company within company who will make electronics for our own vehicle. Like Delphi was part of General Motors, Visteon part of Ford, and then they were spun off. We are still part of our own company. And so we would deliver solutions which external tier were not able to match our price and time. So after 4 or 5 years of successful performance, suddenly this vehicle started reporting loss of pickup and black smoke everywhere. Loss of pickup, black smoke, loss of pickup, black smoke. And culprit was traced to a small electronic unit which we had built for some fine tuning. For some fine tuning of emission versus performance. The emission and torque, this is a kind of balancing trick, and we helped our company by putting that. So we will change that. It was working. So it came for us to diagnose. Everybody started saying your design is wrong. I said your design, not yours. But that is how the world goes. I only came like Meribara. I am coming today. We found that one capacitor was acting as a resistor. Even that time I had 20 years experience. I said this cannot really happen. This can happen only if the capacitor manufacturer has been. But the question is, for all these years it was working. That can be definitely investigated, but unless capacitor manufacturer has made a mistake, this cannot happen. There was loud debate, heated debate, shouting, saying, kind of loose comment started. I said, okay, you know my circuit, I don't know. This is a capacitor, this is a data sheet. You tell me which parameter, which line in data sheet I have violated. Okay, it is my circuit, I have violated, I will correct it. Till that time you cannot say this is wrong, but that is what is system engineering. Being able to say that what this capacitor does, I know how it impacts the person who is driving, which I must know. That is system engineering. I knew that this is data sheet. It is 63 volt 0.1 microfarad capacitor. The circuit is hardly 12 volt. From where it is, what is getting violated, that if you say this is wrong, you don't say wrong. You point out, I will change. And we went to the capacitor, we also started arguing similarly because they have to hide their mistakes. And they are again same question. You please tell me what is the data sheet. And actually that has given rise to another module, data sheet literacy, which I have delivered to many of my global clients. So I will not go into how emissions, but what was happening was when we confronted that manufacturer, he agreed that his dielectric manufacturer. Now you can say tier 0 is OEM, tier 1 are we, tier 2 is the capacitor, tier 3 is the dielectric. He had made some cost saving, okay, by reducing the amount of dielectric without taking into confidence anybody. That's what he said. After 5-6 months it is giving away, it doesn't get exposed earlier. And people are asking me, this capacitor is being used at so many other places in the circuit, why is it not a problem? I said, there also it will be getting leaky, but it is not impacting here, it is correcting my decision logic. Emission versus torque, that's why it goes into black smoke. Emission control, why electronic center? Because every second you have to actually take a decision through electronics. Should I give benefit of emission? Should I give benefit of performance? What is the driver wants? And really walk the balancing trick. So for that decision this was used, and that decision going away, definitely it was going. And then we changed the vendor, we said enough of enough. Change the vendor. So if the system is not used, what other people do? People are shouting, you immediately say, okay, I am changing my circuit. And again 3 months same thing will happen, where are you? The system is doing that. Another thing was, I am coming to the end. The last thing is again the same gold card, because it is very recent. The gold card people, autonomous, and they were told by the gold card authorities, you give us a handheld terminal to summon the gold card. Earlier there is a driver, you can call him, or somehow there is a way to get the driver, and there is a schedule also. So you give us a handheld terminal. So people said, okay, they had a very big Android team. We will give you cell phone, which will have GSM, GPS, and your menu, and you summon it. It will take you. It will give you whatever you want, plus help button, emergency button, all these you. But the cell phone authority says, no cell phone is allowed in our golf. Why? People play with cell phone, not with golf. You also order food. So please don't even utter word of cell phone. Then again they call me, you are our consultant, please give problem like catering. I said, but I am not at all an Android person. How do you expect me? No. You say you do anything, give customized hardware, software, but you solve this problem. But then I said, this is if I do customized hardware, it is a more than a year project. This is only 3 months you want. But then I said, okay, let me attack it. Actually, when opportunity confronts you, or a calamity confronts you, the way is go ahead up. When others are throwing up hands, okay, I will do it. Then I googled, there are many iterations, and why can't I have a single application cell phone? Application will install, grab your OS. You can exit only if thumbprint of admin is there. That will solve the problem. Okay, that solved the problem. So you say that the golf cart authority will give this cell phone to everybody, issue it. You cannot exit out of it. So customer voice is important. Customer was not saying actually that I don't want cell phone. He was saying I don't want my people to play. I don't want my people to order food. So there is a famous quote from Henry Ford that if I ask my customers, what do you want? They would have said, faster horse, and we see what horses do. So customer voice is the knack, and how my every action really benefits. So with this, let me stop. I know yesterday how the time went away. So I am stopping. Actually, this is a very huge presentation and very, very popular across the industry. Sorry. Some other time. So thank you very much. Any questions you can ask? This can also be used, just 1 second. This can also be used in non-automotive very much. Like the other day, somebody said we want to do smart iron, smart electric iron. And they say we will sense the fabric and give you the temperature setting. I said, who will use it? Get sold. You don't need. You do some put the iron, it burns. That use case is more important. Then we searched internet. The projects are there. They have accelerometer. They have gyroscope. I have forget accelerometer, gyroscope. A simple switch. If you release your hand, it will stop. That is system engineering. So that only the last thing was how you apply the same concept to now. And
Thank you so much, sir. I must appreciate the zest that you have shown at this age, and hence you have proved that age is just a number. Learning can happen at any stage. Thank you so much, sir.
my company is only 4 years young. So my age is 4 years. I am a founder.
Thank you so much.
Separated from the industry, started my own consulting because I found there is so much of gap, knowledge gap, which is a paradise for me.
Thank you.
Any questions either now or any other time you can ask. Just in 30 minutes, but you got the flavor.
Sir, one question.
Yes, sir. Definitely.
You visualize a young generation for India's future.
Very, very promising. Very promising. Much better than us. Much better than us. Short answer, very short answer, very nice. Much better than us. I come here to learn from them. There is no electric iron. When I interacted with the young people, I immediately learned that what they are doing wrong. And this is how the thing is.
Thank you, sir.
I'll introduce myself. I am Dr. Krishali Randir, Principal, Media College. I want to say,
Give me honors. Let me introduce you.
I want to say something that very nice lecture given by sir. I have attended in a few minutes, I can say 10 minutes. But the way he was explaining, it was very enthusiastic and motivating to the young generations. You know why I have asked the question? Because nowadays always there is a discussion the young people are not doing anything, there is no contribution from young generation, blah blah blah. But those who will attend this conference, they will come to know that there is spark, something innovative, something new. After 25 years, maybe the Mesco Engineering College will be in a golden word of India's history. The students have contributed something new for India. That's what we are expecting from you. Thank you very much.
Thank you so much. Thank you so much, ma'am. Students, I hope you all know, ma'am is Principal, Neswadia College of Commerce. She is Dr. Rushali Randir, ma'am. Thank you so much, ma'am, for taking your precious time, and you have come all the way from Wadia College to join us over here. Thank you so much. So now let's begin with our paper presentation session. Before we start, let me give you some instructions. All students, please follow those instructions. You will be given time period of only 10 minutes. Okay? So you have to finish your presentation within 10 minutes. After 8 minutes, there will be a warning bell. followed by 2-minute presentation, and after that there will be a question and answer session of 5 minutes. That's how it goes. Please stick to the schedule. Fine. So I request now authors of paper number 1, CNC laser engraver using Atmega 328P IC. Authors are Jaspal Singh Basar, Tejasvi Jadhav, Authority Tape. I request them to come forward. Even if you don't bring your model Jaspal, that is fine. You can come over here, let the model be over there. If anybody, they can see from back desk also. Just come over here and present your paper.
So, good morning to all present here. Myself, Jaspal Singh, currently a third year ENTC student at Wadia College of Engineering, Pune. So, I have made this machine. It is a CNC 80 mega 328P IC. It's there if you want to see it, the real model. So, now I'll walk you through the presentation and everything. These are the things that we are going to discuss in today's session. So, does anybody know who is the father of numerical control machine? Anyone? So, I will answer this. Sir John T. Parsons. In 1940s, he invented a CNC machine, which is a computerized feed the G code, and accordingly, the machine will. So, the brain of this machine is the Arduino IC 80 mega 328P chip. It is a 20. I used a dual inline package for that, and we are using a laser Gerber and a Gerber firmware for this machine to work. So these are the list of components required. I have discussed a few earlier. Getting damage from its own laser, a warning bell will be initiated if a switch is pressed. And so now let's discuss how this machine exactly works. So basically, there is a software. There are a lot of softwares which actually generate a G code. G code stands for geometric code, which you upload or give it to that particular software. It's going to generate X, Y, Z axis coordinates, which are known as G code. The software that I used was a GRPL software, and there is a firmware that is. So what exactly Gerber library does is that it translates the G code into an electrical signal, and that electrical signal is then given to us via the Arduino digital pins connected internally as on top of the board. So now let me just give you a brief explanation of a stepper motor that I have been using. It is NEMA 17 stands for its dimensions. It's 1.7 inches by 1.7 inches. As you all know that if you directly provide a DC, because it needs a stepper motor driver or a stepper motor controller to work, which can be DR8825 or A1488 stepper motor driver. The two most important corrections are the step pin and the direction pin. The step controls how many steps should take to move. It's going to take 200 steps to complete a 360-degree revolution, so that's 1.8 degrees per step. And direction can be anti-clockwise or clockwise. So basically, your PWM pulse width signal is sent via the step pin, and accordingly, the motor is going to move. Is connected on the A1488 stepper motor driver. So these are the important connections. And this is the Arduino CNC sheet. It is a widely used sheet for every CNC hobbyist. This sheet here and it reduces the connections. X-axis and for Y-axis, the step and pin number 3 and pin number 2 and pin number 5 for X-axis, digital pins of Arduino, and pin number 3 and 6 for the Y-axis respectively. The laser module that I have been using, this laser module has an optical power of 3.5 watts. It can give precise engravings on MDF or like. The operating voltages of the motors is 12 volt 2 amperes. Also for the Arduino board, we are continuously going to use. We will be using a USB cable because in order for the machine to work accurately, certain configurations are needed. There are a lot of configurations. One is known as a x-axis and y-axis travel. Basically, there is a concept known as a jog. Jog means the machine. Jog means a software which is going to travel. Jog should match the real distance, and the maximum spindle speed is basically wattage power that the laser will produce, and the rest you can see. So let's discuss the merits and demerits. This machine is accurate, and this is one of it. We can control the speed and the power. If let's just say, similarly we can do it. One of the demerits I would like to say that the initial cost of the machine setup is high. And there is a learning curve. The more sound the operator of the CNC machine is, the better. One of the things to keep in mind is the safety and the precaution. We need laser protection goggles and for demonstration purposes, I have actually. If the machine is big enough, we can this lathe machine, milling machine. So this is the things that I have done. It is Thank you for patiently listening. Any questions?
Questions can be asked.
Yeah.
Okay. Yeah. See, I have. How did you decide on the stepper motor specification or speed? Hello. Decide on the stepper motor torque speed specifications.
Sir, actually, NEMA 70 stepper motor can be precisely controlled. So, and it has a.
How did you decide torque and speed?
Sir, actually, the laser module weight is according to the weight of the laser module that I have been using in the machine. Accordingly, I decided the torque of the motor.
Then I agree. How are you sure that 2.2 kg? Did you do calculation or you borrowed saying that NEMA 17 is good enough for this?
Yes, sir. The later part was
Later part. But now that is inside. That is what the system is all about. See what exactly. Now other people do in CNC. What is the way? Have you seen any other real life product which is so? What kind of motor they use? What kind of controller they use?
Yes, sir. So actually, there is a industrial area and runs an annual training workshop. So I was curious that to know and see BMC machines over there. So I made a miniature version of it.
Okay.
So out of curiosity, I made this project. Step two.
So, but when you see others, what is a motor scale are they using? What is the computing power really needed? Am I over-using my computing power? This is what an engineer is different from us. Otherwise, you are no to selection. Then the learning will be there. May only restrict yourself to the hobbies. Otherwise, thank you very much for your questions.
Thank you, sir.
Method by which you are checking whether the G code generated or engraving you want to put.
Yes, ma'am. Initially, we do the framing part. Once the picture is uploaded on that, whether it is frame, it takes the frame. From that, we understand whether it is coming. Then we actually do a test run. There is
Spacing your so if you so have you thought about those?
Yes, ma'am. Actually, my working area is approximately. And I need to create one more without changing the board. I will set offset. So accordingly, the machine will do it.
Friends, you have any questions? Anybody would like to ask it? Questions? So all are happy.
Good job.
So we are done. Okay, let's move on. Hello. Yeah. Let's move on to next paper. Next paper is by Kushal Thanvi, Gatik Patil, and Ravi Bhattuwar. Title of their paper is IoT-based smart trading. So I invite them to come on the dais. I request all the participants to ensure that your presentations are preloaded on Google Drive link which is shared by us. It should not happen that on runtime we are doing it.
Check slides.
Everyone, I am Ravi Bhattuwar. Today we are presenting IoT-based smart trader with infant monitoring. Nowadays we all know there is a huge increase in the houses where both the parents are working. At the same time, they are having their work also, and they have to fulfill the responsibility of their child. In aim to build this project is not to replace the human touch, but instead making the mind and easier. We have built the smart cradle where we can assist the caretaker for the monitoring and for monitoring the environmental and the other features also. So it has application in the hospitals and the nursing home where the ratio of the staff and the child is very low. The next is that my fellow author Gatik is going to explain the features for the smart cradle.
So mainly like methodology. So our main strategy is to integrate like various sensors that we have used in our app, and we can also access like data that we are getting from our sensors on the app. Digitally we can look at to it, and the proposed cradle is like connected to the app like through a cloud interface called ThinkSpeak, and we can access all the data through the ThinkSpeak on our app also. And mainly the data consists of the temperature. Like temperature is there, like humidity level we can get, noise level we can get, and also there is a camera to stream the live video of the baby if we want to protocol like WebRTC. So this all is the methodology. So features like we have all these features in our cradle: temperature sensing to sense the environment temperature, also humidity to measure the wetness of the diaper of the baby, and we can get that like this on the app also, the humidity level. The LEDs are for at the night, means at night for if there is an emergency we can on this. Fan for the cooling purpose which we can control through the app. We have the start and stop button in the app also. And speaker which is for the entertainment purpose, like we can play songs and various educational content on the speaker also, which can also be controlled through the app. Also we have sound sensor for the noise detection. So mainly sound sensor, like if there is any noise detection, so we can automatically control the rocking mechanism of the cradle. Like if any sound is detected, then the alert will be sent to the app and we can automatically control the swinging mechanism of the cradle. Camera is also there, like I told, and the weighing scale which measures the weight and which can be shown on the app digitally.
So how does our cradle work? So what happens is that we are just trying to design a cradle which tries to integrate the IoT and sensor data, etc., so that it can be monitored and stored at the cloud. So what it does that our app can also directly connect to the cradle, and it can connect to the cradle via the cloud as well. So the profit of that is, if it is connecting via the internet, we can stream the cradle from anywhere in the because there is a lot of latency when connecting to the internet without the use of technologies like edge computing, etc. So we can connect to the cradle through the local Wi-Fi connection using our app. So this is how the app actually works. So after booting, it first performs all the hardware checks, so if to see if all the sensors are working or not working, and then it connects to the internet through the local Wi-Fi network, and then you receive the commands and send data through the internet. So this is the same about, these are some screenshots of how the app looks. Okay, so a market comparison. So currently in market there are some products which are sold as the category of smart cradles, etc. But mostly they just include a single motor which can be used to swing the, and some motor-based mosquito net, etc. And they are almost always more than 10,000 rupees. So we were mainly, our aim was to create a similar product but much cheaper and using a lot more functionalities. And the main aim of this is to not only we are providing this, we will want to provide this as a household product as well, but the main aim is that lot of children that need to be taken care by a lot less staff. Because even in hospitals, if you go to even the big hospitals nowadays, there is a lack of IoT in patient monitoring and all that. We will see that the nurses will come, take the temperature of the patients, take their BP, take their pulse. They will jot it down in some file and do that. Now, with the rise in this IoT industry, we want that thing to be also automated so that the nurses can focus on more important things like attending to patients and not just getting basic data. We were also thinking that after it starts collecting a lot of data from the video feed like posture estimation, etc., it can be used to also gain medical insights on children, like if some children are on any medication, does that medication affect the children's sleep cycle? Does it affect how often he cries or if it causes any discomfort, etc.? So like the main aim is to get more IoT and sensing technology in the medical field. So like we are thinking of starting it through the cradle, but like that is our main goal. Thank you. So any questions?
Can I ask? Yes. Very concept, I must agree. The temperature sensor is digital. This is digital. What is the physics behind this temperature sensor?
Yes, sir. No, digital means we are actually using the THT11 temperature sensor. So it's not actually digital, it's analog temperature sensor only, but it just provides the data.
Yeah, digital sensor with limited accuracy.
Yeah.
What is the accuracy you are looking for?
Like for the general environment sensing, we are not looking for like plus minus half a degree is okay.
Environment sensing or
So the child sensing is not actually done to the DHT11 sensor, which is more like the ones used during the corona, because we can't like physically touch the child.
So humidity also is
For the environment.
Yeah, but you have to talk to the parent also.
Yeah.
That is one. What is the, how do you size the motor? Torque, speed, and mean by 180 degree, how does it work? 180 degree motor.
Yeah, so sir,
First, how do you come up with torque and speed?
actually decided that according to that we just like thought what can be the easy to use and cheap motor that will be like good enough for moving that crane. We have not like optimized the motor like it should be not far. Actually the motor we are currently using far exceeds the capacity. It has more than enough torque to like, it has more torque than needed, but like we use that to first generate a concept, but we are yet to decide like.
But how do you know it is more than needed?
It has a torque of 16-17 kg per centimeter. So like small babies or young babies do not need that much.
Do you calculate?
Yes sir, not like specific.
Benchmark with the actual product. What is the kind of motor they are using? What do you mean by?
There is a internal like that in that so it does not rotate after that.
After that, so you.
Then it's ideal for swinging type of a movement.
Need to talk to a parent or the people. What exactly they do. Nobody worries about temperature. Generally.
Yeah, actually, sir, we also went to some general pediatricians and as well also.
Okay.
Like asking them, okay, if you are creating such a product, आपको like what would you want in such a product, right? So mostly for them also temperature and all were okay-ish thing, but they were more like, okay, weight is a good.
Somebody has kept the baby on the cradle. I don't expect to wait there.
Yes, they don't. They already have a different way.
Okay. So see, this is what the bigger picture. I will check that has to be. Otherwise,
Thank you.
Hello. Yeah, so said nice concept. I just wanted why you chose this work.
Sir, actually the motivation behind this was that we have seen a lot of hospitals recently because of some medical emergency. So we saw that how the nurses won't really come very fast and like they are busy care. When they go on rounds, there are a lot of wards, right? General ward, private ward, these wards. And they will go on rounds just taking basic data. Like they have a pulse machine and these different machines, temperature machine they will take. Yeah. They will be busy on those things while like patients are running, the IV has run out, we have to stop that and some injection is given. So like specifically we chose babies because this was more of a application that can be used outside of hospitals as well because we have included some features for entertainment purposes and which are also not available in many of the commercial products. So yeah.
yeah, just I want to add. I have been a parent. When you become parent, you will know. Nobody is going to entrust your child if there is no person.
That is true.
India population is so much. You easily get a person who will sit there, and generally you like to when you give birth.
Yes, you.
So we have to see that. Many times what happens, you turn the problem around application to suit your mind. So that pitfall you have to avoid. But when you go on selling it, people say I don't know.
Yes.
So actually means we had like to target to solve the real life issue. So we are seeing like parents are working professionals, so they are means like they are not able to do like monitoring. So it will be helpful for them also, but mainly the app which is there. So it has an unlimited range because it can be connected to the cloud interface. So they can control from office also. This is the main.
Parents would entrust their child to a place where there is a person available. Generally, you ask any parent of the world. Person. That is what people do. People will not say that I am working, let the child be there. If at all one of the they leave their job and they see, or without, I have not seen anything. We have not done and we have not seen. Unless there is a human being attending to the child, no purpose. Okay, you will not say, let the child be at the mercy of this idea. No. When you become parents, you will know.
Okay, thank you so much. Now let's break for coffee. Post coffee session, we'll have session on Dr. Manoj Jain, followed by 2 more paper presentations. So I request everyone to please come back within 10 minutes so that we are sticking to the schedule and we don't run late. Thank you so much.
Can be seated. That's okay.
did you make a study on what would be the fallback arrangement with such lovely technologies like cloud and internet? We are not able to still receive small, Wi-Fi connection even in the house. To be honest with you, that's what I'm observing. The internet signal sometimes is on one band. If you go in the bedroom, it doesn't. No, it's okay. That's okay. You're almost on the way. That's okay. Thank you. So, what are your thoughts on that? First, I observed we said we have a staff to children or babies ratio would be less, right? So you're trying to control it. Nursing home especially. What would, God forbid, the inverter, just as Mr. Vishwas said, anything can happen. Honestly, my session will be on that mostly. We're getting so carried away, and if I was to say precisely, we're getting so dragged away, but even the basic necessities or IoT, I don't see that fulfilled, and we are firefighting in industries. Small apartment, if you call and say you don't have a signal on your cell phone, the first answer is, where are you? In your bed. How do I have to describe my whole house? How many square feet and how many square feet I'm within? Where is the tower? So coming to the question, what would happen when the nurses are 4 and there are children maybe 40 and the cloud technology drops or instant, like power failure, so frequent. We are talking about generation, 22nd generation. We are talking about Gen Z. But honestly, I am very disappointed to where I come from in 90s and where I am today. I don't need to walk down and wiring ourselves each day, creating more jobs for data science. When you see, it is very discouraging for me, it is very disappointing for me. So, sorry.
Yeah, yes, your concern is actually right. So after the power failure, there is no way that a cradle can. But the thing is, like the cradle does not have any just sensing data and using for entertainment of the baby and like helping the staff. Like that was the main thing. Someone being over there, but it was just assisting someone. Even when the power does fail, like there is no harm to the baby that is happening. Wi-Fi, etc. The app can actually connect to Bluetooth as well to the cradle.
I feel it's kind of more, as I think I'm on lines with Mr. Vishwasan, like it's putting little additional responsibility on caretaker. That's my personal take on that. Secondly, I don't know how much of market will accept it. I don't know if you have done research on it. So that's my fear about it. And in my fear with any, it's not specific, I'm talking to you, credit system, but we need to simplify life more. It used to be way much better. Sometimes when I used to go to the engineering college on a bicycle, college in 15 minutes, maybe on a cycle, but now even with scooter. So that's my concern. Concept is good. You may apply that concept in other, when I'm talking about IoTs or iOS. Thank you.
Thank you.
stipulated time. Settle down. Um, so very blessed afternoon to one and all. On Vishwas sir, Honorary Dr. Vishal Deshpande sir, other team. Support staff, my dear students and friends, more than students. Honor and privilege to be present on this lovely occasion. Synergy 2024 International Symposium bringing academia and industry together. It's a very interesting topic which Vadia has chosen, and being an electronics engineer as at the core, I was very thrilled when I realized about this symposium. So, first of all, before I dive into my congratulate Vadia Modern Education Society's Vadia College of Engineering, and congratulations for successful completion of 25 years. Big round. Again, I know we are running sort of disturb my purpose. Usually I have a ritual of starting with expressing gratitude. I usually keep myself away from the technical sessions and looking at the schedule and timelines, I take a last minute decision whether I should go for technical or something personal or personality related. Most of the cases I end up doing personality and gratification. Reasons you will realize when I go my speech. So, with your kind permission, and to energize you all, I'll slightly more up by expressing like 2-3 minutes of gratitude to the universe together here. I will walk you down the steps, and I promise you it would be an amazing experience for you all. So, I love the light background music. Let's take a moment to thank the universe and all, to thank each and everything which we have around us, which we miss, chasing our dreams, chasing our future, chasing our livelihood. It's like background music at a specific which enhances the experience, I would say. If you sit straight with your shoulders high, your eyes for a moment, and walk you down the procedure. Around you. yourself standing in front of the mirror. How beautiful and handsome you look. Slowly imagine the face of your mother. How proud she feels about you. Face of your father, your papa. How secure you feel in his presence. For you. How safe you feel in your home. Imagine your institute. How proudly you walk in the institute. Yes. Support staff can arranging everything for you. The desk, the infrastructure, the vehicle that carries you back and forth, taxi service, everything and everything. Express your heart, felt gratitude. Time to peek inside yourself. Proud of yourself. It's time to come back to and arms gently. Clasp. How do you feel? It's like a reset button, I would say, maybe, being from electronics. So, small daily things, we don't really think about. They have a major role to play. Now, coming to my topic quickly. Something that struck me based on this theme of the industry and academia. I would definitely extend my thanks once again to Mr. Vishwas sir setting up the platform for me. There is a gap. I totally insightful, knowledgeable, eye-opening session. Thank you very much for that. And I don't have any slides, so that being a tech talk kind of thing, I believe it to be more slides. You can always dig through Google. And you are here for presenting your, so probably you're filled with all types of technical thoughts. And pin number 2 and pin number 3. I used to do that about 8083 microprocessors when I was in. So I don't want to bury you more into that. I start with a different angle. Chance to interact with the second paper present. You probably are most of you are final year, right? Okay. Before I begin my topic, I've seen something which is kind of making circles around, which is outcome-based education. Now, what truly outcome-based education means to me, I didn't find relevant information while I was Googling. I thought this could be a good idea. I mean, I wanted to talk, and I said, what's been already covered, I don't want to go over it. Because if I was to go over the information in different form available on the net, or doesn't matter on media or in some courses, I won't justify my presence with experience of almost 3 decades abroad. So that being the reason I don't have slides. I want it to be more interactive and bring reality to your step, I would say. Now, having that been said, honest, brutally honest. No, actually, I appreciate your kindness. I would leave both the extremes, but I would be honest. I could be nice, which I don't want to be, get you nowhere, and again the purpose. I would just be honest. I won't be brutally honest again, because that would become too much of a criticism towards nation or entity, enterprise, individual. I would not say it to be a disclaimer, but I would apologize before beginning my session that I don't mean to promote any business entity, nor target any business or entity or any person, nor criticize, discourage, or demoralize any student here. And sincerity, I would try to share my reality, what really is needed when you step out of your courses, whether you're pursuing higher education or otherwise. So, let me ask a simple question to all the students, I guess, are on this side. Some of them, I think, have joined there. After you finish your graduation or post-graduation in electronics, if you were to see a placement advertisement, those are looking for jobs, looking for anything in the operations side, I would say. Planning engineer, production engineer, supervisor, shop floor engineer, engineer, of course. And it appears from automotive segment, medical, or wherever. And it's from operations side, operations and supply chain or operations. So as an electronics engineer, you see an ad. How many of you think you would be applicable? And anything in operations, in automotive, in publicity, construction. Show of hands. How many of you think, can you apply when it's an ad like this? Do you think you are applicable? Yes? And why would that be? Yeah.
Sector mainly, like my interest mainly, I would like to see the internship that I have done in automotive India, and I have various modules that means develops there, and the various modules like eco-thermal module, and also done the testing on various pressure, temperature or levels, various parameters that they have set on the data. So mainly in automotive domain, I can say that
standing up and speaking up, that's great. That's really appreciable. I appreciate and I admire your confidence. That is really, really applaudable. Actually, I want to break this myth here. Ones who did share or answer, they are in a fix, which is not unusual. Because that's the way I feel still things. Employability. Not sure about the other third world countries, unfortunately I never worked there. But coming to Europe or North America or Americas, there's a total different view. Still, when it comes to the industry, academic placement is purely sorted on the basis of BE, electronics, and medical. I want to break that myth. I completed, as I said, my graduation in electronics. I successfully, it's not fair to say, but I successfully stole job from textile engineers, from automotive engineers, from computer engineers, from IT consultants throughout my 3 decades overseas. And when we are talking about networking with the industry, my first point is if you are looking for a job overseas, some may go via the route of higher education abroad and then get hired there. Because I think the return rate is very less. Once you do your masters, there is a very less likelihood of you coming back. Single child of your parents and also. They look at it differently. Looking at the way a most populated country, I feel very sorry. This is the message I want to on this platform where we are trying. In operations, I've always seen various types of manufacturing, just in time, batch processing, this and that in my initial lovely good years. Is happening. Unfortunately, I've never been into academic. My major serious concern and appeal to all of you in your research, one, don't write just to write an article and get through your course. If possible, try to see the real and look for solutions. Don't try to rep or upgrade as Dr. Vishwas sir has prompted in that CNC thing. Don't just try to replicate with the latest technology. Or I took this stepper motor. All this. There's not much of a value addition in organizations. All they think about in organizations is what you can bring to the. So coming back to the point where I was, if you are trying to go for education, upgrading and higher education abroad, you definitely right now, if you can think of what you want to be in your rest of your life as a career, as a profession, or even if you want to pursue, have your own business with here, you need to clarify, you need to have complete clarity about that. Otherwise, you would really energetic. You know, you have seen those that wanted dynamic, energetic, like you would waste your lovely good years when you're full of energy trying to chase something which you aren't even sure of. You're chasing something because everybody's chasing. Then you realize at the end, actually what was I chasing? Why were you running? Because he was chasing or she was chasing. Oh, and at the end you realize there was nothing. And you wanted to be somewhere else. And you lost your peak time during that. That's what I did, and I learned the hard way. So if you're pursuing your education abroad, if you're going to work abroad, you know what? It is only with great regret I would say, all this technical stuff, until and unless, not my words, you are in research and development, you are aspiring to be in NASA somewhere, you want to be a typical scientist, yes, then just pursue that with your heads down. If it is more other than that, most of the other stuff, trust me, whatever you learn in schools and colleges, so don't get crazily mad about what you're studying. I'm not saying don't study. But engineering, nothing wrong with that if you're clear with your goals. You have heard stories about so many dropouts from Harvard. They were not crazy. They realized their goal. You know, IBM or whoever was the router manufacturer. Mr. Honorable Vishwasar took me down the memory lane when I have started my career as a dynamic testing engineer. Simulation, lovely simulators. Every morning you're fighting a war. How many cards, how many jigs, this and that. And with all that, still, in the present era, we are talking about IoTs, iOS, IIoTs, this smart city, smart apartment, smartphone. But what about smart ourselves? You can have a high-speed internet, topmost speed internet. You can never imagine on planet Earth. What will that be good to you when your brain is slow? You cannot grasp things. That's analogous. It is not something superficial, I would say. Look at my parents, for instance. They still like the Nokia phone. They don't want the smartphone because one finger of theirs is together. So are we wiring ourselves? Are we just chasing something which we are? What about quality then? If you are not into technical stuff, it's okay. Just follow what you say, go with the flow, get your degrees. But if you don't want to be a mathematician, why bang your heads on mathematics? Tell me a simple thing, right? You don't want to be a mathematician. You want to be as a mathematician, mathematics professor? No. So what do you do? At grade 11, grade 12, what do you do? Some people who are not smart enough, because of that, they leave mathematics. They take PCB or whatever. But others, no, because you merited, you are that. And that's the thing I'm coming to. You come to your higher secondary, I would say, and then you go to, I'm pursuing medical, law, finance, IT, management, and then you end up saying, And if I was to ask, I do question whenever I bump into some Gen Z students, so to speak, and why did you enroll in engineering? What drives you? What's your desire? What's your passion? I got admission easily. I was a merited student. That's it. What after that? No idea. Medical. Are you intending to really serve the community? Or did you join medical because of XYZ reasons? So community or just because it's a high-paying job? Here in medical, I don't know if it was bureaucracy, that's what I apologize in the beginning, I'm not targeting. in 30 lakhs, 15 lakhs, 4 years medical, Uzbekistan, Russia. I'm like, what the hell is going on? Why don't we have a sustainable education system? Is our curriculum. When I say this, I'm getting on to the next topic of mine. Why do we go for higher education abroad? That is my next question. I want to prevent you from dozing off, so let me wake you up. Why do we go for higher education abroad? Anybody? Please? We go for higher education. I want to pursue masters in Germany, Australia, New Zealand, Canada, and America, and wherever, Germany. Why? Why would you want to go for higher education abroad? Don't we have IITs here? Or is 2 plus 2 equal to 5 there and you are one step ahead? Why? We have respected someone who is there. Sorry. Why would you want to go? Any guesses? Any answers? Nothing is wrong. You can speak a heart out. You thought you decided many of you would go for education.
What's the better career opportunities and the
Excellent. Very good answer. Right? Right on dot. Very good. Thank you. What's your name? Neeraj. Thank you, Neeraj. Precisely answered. What's happening, I witnessed that. And being from research, I've been a doctor. I felt like exploring that. What is different in colleges here? Whenever you go to Canada for a job and then, getting your citizenship, the experience they're looking for is, do you have Canadian experience? Of course, I did get a job, which will be my last topic to discuss. I went to college about when I was 40 to 40 for project management accreditation. Because when I had to sign as a coordinator, I could not be a manager because I didn't have a qualification, Canadian qualification. So I joined a college. In the evening, I would go 3-4 hours. Basement off. Whether it's snow or shine, I had to drive a car in 3 feet snow, and I did it somewhat the other way. And not to brag about myself, I come out with honors as a first student in the youngsters. Okay, I thought maybe, I cannot generalize this achievement based on study in one college. And based on my achievement, the organization asked me, you are smart, you are meritorious, you are good, you are hardworking, you are capable. Oh yeah, bring it on. Next comes the construction industry. PCIC Canada sends me for a blueprint course. Okay, every day I go there, same story again. So what thoughts I had in my mind, I could kind of attest those thoughts. Those are the relevant, real lifetime experiences I am here to share with you, which you kind of sort of came right on what was mindset. It's nothing to do with the education there. You know what? With the 2 instances I mentioned, I'm trying to pinpoint fundamentals. We are really good at that. We get hammered, we get slapped, we get kicked, you can't imagine all kinds of brutality, so to speak, we go through as a kid. That's not the case there. That's why those kids, they drop out after mostly high school. But here, no, we get all kinds of there you can't touch the kid. So they are dropouts. But the flip side of it is, because they are dropouts, they know they have nothing better to do in their life. Because they can be dependent on their parents, they start going out for certificate courses. Accounting, finance, PLC diploma, automation diploma, Java programming, and all those new programming languages. I had Fortran, Pascal. I made my way up to Excel, I would say. So I consider the reason I smile is I would consider myself fortunate also to witness Industrial Revolution 4. I started with Industrial Revolution 1, Industrial Revolution 4. So that's what those kids miss upon, and what happens to us. We go happily, smilingly, happy day, merry well, and all our graduation and all this zeal, all they do is nicely wrap in a gift wrap. What changed all of a sudden? Is that higher education, like PG programs, totally different, or the fundamentals the same? You learned about sensors, you learned about automation, you learned about. For some, it could be status symbol. And definitely, I have a. If it was really so good, there is no scarcity of rich people in India. Filthy is poised to be ranking in rich people, I would say so. Why don't you send the kids? Why don't you relocate the kids right from kindergarten, nursery, primary? If it was really something quality, why? They can send the kids. They can send caretaker, nannies, whatever. They can send the whole nation out of there. But that doesn't happen. But now you might say, okay, I'm seeing both the pros and cons of the Western kids and our side. Let me get to the core of it. Let me get quickly to the core of it. Basically, most of us aspire to what you call the basic life necessity, or you would say, which we compromise on, which is health, relationship. There comes the money. With money comes good health and relationship. So think about what you want to chase in your life, in India or abroad, and accordingly shape yourself. And what traits would lead you is confidence, soft skills, public speaking, personality, because 80% of these skills, your higher ability overseas. Here, I don't think I have any comments. Here, you know better than me. And my little speech. Thank you for listening patiently to me. So much. Wish you all the best for your future endeavor. And at this prestigious event. Thank you so much.
Thank you so much, sir. And my sincere apologies for curtailing you. Extremely sorry. We are since running a little bit late. That's why I have to curtail you. Thank you so much once again. Now, I must appreciate the hard reset button which you pressed. That was really needed. And there were many takeaways from the session. Particularly, the biggest catch was one should follow one's goal. Right? So, with that, let's move to the next session. So I invite our paper number 3 authors, Chaitanya Poredi, Sagar Wankhede, Megha Patil. They are going to present a paper on multi-criteria decision-making based material selection for printed circuit board utilized in robotics application. They are from Symbiosis College. Let me just once again remind the rules. 8 minutes for paper presentation. This will be followed by a warning bell and then a question and answer session.
First, I get blessing from Sir Sutima because the knowledge are given to me is really grateful up till now for my life. I down my head, great knowledge has been given. So my name is Chetan Kapuredi from SYMPOSIUM Christian Publishing University. So my paper name is Multi-Criteria Decision Making for PC Material Selection for Robotic Applications. So I start about. So this would be the point of contents during my presentation. For introduction, literature review in this slide. So signal routing, minimization of integration. The electrical signals have been a crucial role while signaling the components to components and giving the same signal value for the output. So this would be the main criteria for my signal routing while taking object. Importance of PCB in robotics. So basically, the layout designs, the designers make a crucial role while designing the PCB for robotic applications because they are while layouting, it's an important task for component selection while selection of the needed components. The third important point is customization and feasibility. Yes, so actually we need to think more for this customization and feasibility. So for custom designs, like I need to move a robot from one hand to other hand. So like for this, we need to complete basic knowledge because this will be the part for my robotic application based programming because the controllers and the signaling, what type of controller I am using and what type of component I am using, this depends on the whole customization and feasibility, the minimization and the signal routing. So robot plays also reliability because if you think of reliability, it plays a crucial role in robotics. If a prototype is being used, it is okay. The FR force and the polymeride PCBs. So for that PCBs we are totally relying on the whole of the system in PCB. So the reliability comes in a great manner because it should not damage any of the while being operation in the sequence. Then scalability reproducibility. So while replicating on PCB design in finalization state model. So we need to think of this point as well as scalability reproducibility. So the model PCB design is being adapted in a justice for the same PCBs and design modeling. So this would be the major point of consideration while temperature performance as example, while always think of the power consumption of the on PCB. Let's take a component has been heated more, so it may cause a major damage to my PCB. So I need to also think of my component selection also and PCB material also. So for PCB material, I am using polymer and FR4. So that the temperature is always been a major part of while developing or designing of PCB. So this would be a major factor for it. The mechanical property is that it should not be of shockage. The whole proof. It should not be in likewise. We should not think of the. We should always think of the mechanical properties as compared to doing the PCB design in consideration. Then cost consideration, one of the most important, because while designing frequency of PCB board, the cost comes always in picture because you are handling lakhs of some units of this cost. But while the system designing one of the component, your cost should be lesser as compared to aspects and environmental considerations. As again, before only temperature, then water absorptivity, it should absorb the more point, so that it will cost the more flexibility in your PCB design or PCB manipulation. So this was my literature review while I was preparing or making a research on my paper. So these are some of the literature reviews. These are some of the literature reviews in the PCBs. Literature reviews. Yes, sir. So basically 5 aspects, main C1, C2, C3, we are listing below. Volumetric resistivity, water absorption, dissipation factor, and direct constant. These are some of my most important 5 aspects for designing of load PCB in multi-guided decision making. So this table I have built for properties of PCB material. This ranking is for seeing the number of the PCBs. So these values are come from some scientific research based on the values. Let's take C1. Let's take C1 as resistance. So for FR4 is 39400, and for polymer it is 70,000. And you can think for what electrician it would be designed for polymer and for FR4. That's why I make a multi-criteria decision making while selection of feasible, because it's an important parameter into this. So the normalized decision table I will think of Alpisten Mura criteria. What is Mura? So it's a multi-objective optimization and ratio analysis for designing one of the isolation of the boards. So basically it's a mathematical model type of formulation, normalization, standardization. So there are some couple of formulas to be implemented as I'm showing in your PPT. Basically selection criteria is decided on these factors. Mathematical model, I repeat once again. So basically, matrix table, and the W, what you see in this. So C1, C2, C3, C4, C5. So if we divide 1 by 0.5, it will be given as 0.2. So my normalization criteria for this is 0.2, as my result is being. Calculating and formatting for this. I will see that the tables will be decided in the same particular way, manner is being calculated. And so I will reach to conclusion. So that is why during this, I think that polymer is the most important, because the ranking was 1. The ranking was 1 as per this criteria. So polymer ranks 1. Then we think of bismuth triazine, that is epoxy, second type. Then FR4, because FR4 now is a widely used in robotics applications, or in basic circuit you can use FR4. You see FR4 green board of PCB, so that would be FR4. Then we are seeing the rankings and the silent ester having the last number of rank, 6th rank as per material. So this would be my conclusion of ranking of the PCB material selections while during dealing of the for robotic applications, for multi-criteria decision making, for electrical strength, resistivity, water absorptivity, dissipation factor, electrical constant. These are some of my important points which I have been concluded here. So that would be this would be the most of the selection criteria for PCB selection. And these are some of my references. Yes, thank you.
I have fundamental questions. Being PCB used for say Arduino, if you did not go the application specific, what do you think may go wrong if I use that PCB in a plain robotic application? Because when I go to automotive, we don't worry about it. It is much more harsher. We go by epoxy, it works.
Okay. So, sir, first one is as per your question, it is application based. So you are using Arduino Uno.
Same PCB material is Arduino. That same material.
Okay.
What may go wrong?
Sir, dissipation factor or power density.
No. Okay. Let us stop here. Dissipation. Can you tell me an application where the dissipation in the insulation of your Arduino PCB will be more? Why should it be more in the robotic application? Can you correlate it with suppose there is a moving rope from here to there? Why should it make more dissipation?
Why should it do more dissipation?
Not you. Why should it make more dissipation?
More dissipation.
Yeah, we can place. Why should it more dissipation?
Okay, so actually, sir, because the components we are designing for on PCB.
Yes.
So the I square increases. P equal to I. If you think of V into I.
So
Power equals to voltage into current.
So
as I increases, the power also increases.
come on, yeah. See that I square R is all about component.
Component rate.
Okay, whereas the insulator, it is highly capable. Any insulator can take. It doesn't dissipate. It will dissipate only if you put kilowatts across it. Okay, it will not dissipate.
So, sir, while dealing with all of this, material selection also a base capital, because if you think of FR4 and
Can you please answer my question? Okay. I take the same material used the mill Arduino circuit. I take that material.
Okay.
And populate my circuits. Everything else is different. Only material. What may go wrong? Dissipation will not go wrong, but dissipation is taken care by component selection and track.
Okay.
The insulator, material is all insulator. It will not at all matter.
Sir, as I am comparing 5 points, electrical strength,
Electrical strength, okay, follow. Electrical strength, kilovolt by electrical strength. In peak and peak resistance. It is low voltage circuit.
Sir, actually there are 5 considerations.
Let's focus only on electrical strength.
Okay.
Don't go to 5.
Okay.
Electrical understanding is kilovolts.
Kilovolts, okay.
We are not using any kilovolts there.
Okay.
Why should I worry about electrical strength?
Like, electrical strength is the most important.
Why it is important? There is no kilovolts.
Sir, it's an important factor because
No, it is important.
Because- okay.
With the application.
Okay, so let's take an example of 5 volt design. Let's take example of 5 volt design.
5 volt design. Okay.
Let's take Arduino works on 10 and 12 volt.
Yes.
So I'm moving my pick and place robot and controlling with my Arduino.
Yes.
So in that case, electricity would not be much more.
Will not be the matter at all.
At all.
Yes.
Negligible.
That is not required. So 2 factors already dissipating electrical strength not required.
So
Third one.
the resistivity.
Resistivity also, it is infinite resistivity. The circuits are similar. Resistivity will not play any part. Fourth one.
So the direct constant.
Dielectric constant will not again that is any part as far as electromagnetic is concerned. Fifth one.
Surface absorptivity.
Surface absorptivity, what do you mean by that?
So like
Moisture also the same environment, Arduino works, same environment, robo works. It matters both. So generally, the same thing will work. Automotive is much more harsh. I use the same PCB. It works. Okay. Unless you study application, you should not evaluate the PCB. And many of 99.999% will find the same PCB works everywhere. PCB technology is matured so that the business case works out the same PCB across the application, the same material uses. Unless you have very specific like ID application where it makes sense. Thank you.
In your matrix. What are the fields in your matrix? What are these?
They are the number of the component 3914.
So how many you will get? It is 1, 2, 3, 4, 5, 6.
6. So it is 6 into 6.
It is some optimization parameter which you are applying over.
Yes.
That is what I
Yes,
said.
ma'am. Yes, ma'am.
So what does this mean?
I mean, basically it's a P is a formula which so it's a P is 1
P
into
and C relation, can you tell me more?
1 cross 1 is the column 1 and the row 1. Of this yes, ma'am.
So are they related then? You are optimizing what that I am not getting.
Okay, so you are optimizing.
Achha, so then you decided to divide by 2.
Yes,
So you are simply
evaluating
scaling it down and scaling it
scaling
up.
up as per
So 4 kg washing machine, 6 kg washing machine, 8 kg washing machine will have different PCB layers.
as per complaint because the application is more in that case because if I think
You will have not have different PCB for kg, 6 kg and all.
single kg but as per if the component size is being varied if the application is being varied we can think of that.
Thank you. Let's move to next paper. So title of paper is Wirelessly Empower Your Arduino, the Magic of Over-the-Air Updates by Vishakha, Yash and Vinith. I hope you remember the notes.
Good afternoon to all of you. Firstly, we are pleasure to discuss on the topic that which is relevantly increasing in the embedded systems and IoT, that is over-the-air updates. Our topic presentation topic name is over-the-air updates. Wirelessly over-the-air update your Arduino using Node MCU. In this presentation, we will discuss about the topic that what is OTA, how does it works, and now why we use this topic over there, because as we know that nowadays electrical vehicles are in boom, and if there is any glitch in our EV, then it is necessary to us that we should go to service station and update that glitch. So over there updates are revolutionary method in this. Now, what is over there update? What is OTA? It is updating process or updating data using wirelessly. It is revolutionary method, as I told earlier. And why we should use OTA? Because as we know that in this we use Arduino. As we know that Arduino, to update Arduino, we should connect it to wire using USB cable and to update it. We use here ESP module that we can update it over there, because in automobiles the boards are connected inside the vehicles. So every time it is very hard to, it is not possible that we should remove it and update any code and resolve the issue. Now, according to our literature survey, we have studied that Wi-Fi is a very efficient method to update the any board using over the air, because in comparison to Bluetooth and And UART is most efficient and most supported communication protocol by ESP and Arduino, as we have used ESP and Arduino in this. Types of OT updates. There are two types, SOTA and COTA, software over the air and firmware over the air. We can understand this by considering a scenario. Consider a scenario that there is any glitch in our infotainment system. So we can update our infotainment system like HMI and various infotainment system using the software. And same in firmware, if there is leak in our EVs, consider that in our EV BMS system, there is any glitch. So we can use firmware over the air update to update that firmware that to increase charging efficiency and all. Now I will hand over to Vishal.
So, to start with our work, we first studied how the firmware updates get for the original, how the Arduino gets updated to the IDE. So, for the process there was, firstly we compile the code which is needed to be updated. Then the IDE internally first resets the Arduino and it enters the Arduino in the bootloader mode. And, any firmware updates which are to be implemented should be made in the firmware bootloader. So by resetting the Arduino, we enter it in the bootloader mode, and using the USB cable, which is in short is just a fancy UART communication, as the USB ports are internally shorted with the TXIX pin of the Arduino. Then the upload of the Arduino is carried out through the UART communication, and after entering the code checks for the checksum values if they match or not. When the checksum values are already inputted to the Arduino, the verification is done. After the verification, the whole firmware code is written in the flash memory of the Arduino, which executes the code. So this was a step which we studied for the original Arduino IDE, and then we tried to synchronize our process with that step. So the first step we did is we entered a transmitter code for ESP node MCU. As you know, ESP node MCU contains the Wi-Fi module, and we can pass any value over the air to the node MCU. So using that quality of node MCU, we created a web test server on node MCU which will take input from the user, and the hex file is to be sent. So firstly we created the hex file. For creating the hex file, the steps are to obtain the hex file, compile binary file. The compiled binary file is in Intel hex format, and to convert the Intel hex format transfer protocol, which is STK 500B, we created a source file converter code in Python, using both Python and C language. And then after the hex file is converted into parsed file, which contains the start address of the node, the packets of data, and the place where address where it should be stored. The hex file is uploaded on the web server. So this is the generated hex file. On the right side, we can see the generated hex file. This hex file in the starting bits contains all the metadata of the data, and from this we converted the other file which has the starting bit of the data, the 128 bytes of packets of data, and 9 bytes of metadata, which should be which contains the data should the packets be stored in the flash memory, and the checksum bits. Now that was the part which happens on the ESP side. This now the next step is on the Arduino side. Firstly, we reset the Arduino using hard contains the bootloader mode. After that, which is sent to the ESP and converted into ASCII format, and send that ASCII format via UART communication. And on the Arduino side, as it is already in the bootloader mode, we need not to enter any external code to Arduino. It implements its bootloader and checks for the checksum bits. When the checksum bits are come to be matched, the data is written in the flash memory and then the new code is executed. So we performed two types of applications here. One was software over there and one was hardware over there. The problem statement for software over there was to change the data which is displayed on LCD display, and for the hardware over there we changed the blinking rate of the internal Arduino LED pins. So the next part will be explained by me.
So applications of our project of IoT devices, HMI updates, home automations, just to update the displays or to update the features, bug fixes in healthcare IoT devices, home automation or remote sensing such as in satellites or on the ground or geographical locations where it is hard to reach physically. Connectivity, that is the range for uploading from transmitter to receiver, that is the user and the same server. So that causes an issue. Security, that is the file that we provide should be authorized. There should be no more spoofing or any spam in memory. The file or the new update that we give, that should be able to be updated in the customization. We cannot customize as per the users as of scams and frauds, as there is a security procedure as if it is not as if it is a scam or it is a fraud. Other privacy concerns, the updated file which is sent, we don't know whether it is stored, whether it is taken as privacy concern. Feature scope is improved connectivity such as we can update it long files, secure authorization process such as the updated file is authorized from a user, integrating external memory units in the vehicle, so there is no issue. And we conclude. Thank you.
Say where I started. Initial slides. You said Arduino in automotive. Which automotive you have seen Arduino being used?
Sir, we have worked in ARF.
Then which automobile, please distribute. Which automobile vehicle have you seen an Arduino and USB being used? Because that is what you mentioned in your slide. Which vehicle?
Not in particular vehicle system, but we have seen it in ARI as an intern, and there they were working on a project for using Arduino and ESP, and they needed a over-there update system for that. So there is that is where we got our inspiration.
That may be only the concept.
Sir, this the thing which we are developing here is not particularly for, as we have seen there is interconnectivity issues also. So this is a functionality, not an application based. This functionality can be used for multiple types of ECUs, such as NXP boards and other types of boards which are used in automotive also.
Yes. Yes, but see, automotive is a totally different world. The fundamental concept. To that extent, they may be using. Or this area also, so many colleges, I pointed a lot of mistakes to them. Just because area is done is never is correct. Say area is done it, that's why I know how it is done in vehicle, you have CAN network, Ethernet. They may have OTA nowadays. You have OTA here also, some students. And is there a protocol, the boot protocol you have to study or not? Yeah. How much time it takes? What is the border rate? That is what engineering has. Other Otherwise, I appreciate that you have made a nice attempt, but see, never made lose of the real life picture that was my picture and ARI also. So much I have made their life. So many questions. They are almost stopped coming.
Used for other types of IoT projects also, not particularly for the.
I agree, but there also, I have seen, this is actually relevant there with the mask only. IoT for a customized. Generally, person will prefer a secure over the wire flashing if required. There will be error correction, not taken care. This protocol has to be studied a lot.
Data transfer efficiency, have you measured how much is transmission?
Madam.
Yes, ma'am. We have studied the data transfer over the wired network and our wireless network. So the time period it is more faster by the wire, but the difference is about for 0.5 seconds, not more than that.
Why should it more? Did you calculate your baud rate?
Yes, sir.
So same baud rate, why do you think that is more?
Sir, because only in this case, over the serial communication, it directly transfers. But in our case, it firstly transfers the characters to the ASCII and then sends it. So it gets a operation in between. So that is the.
Why should you do it in ASCII? You can try. What your code is there. Just because wireless, how ASCII and wireless are.
So what happens when it takes directly the data that we have sent. If we have sent the data in hex file format, it actually takes the data. But in wireless, if we send the hex file, now if the digit is 30 and the next digit is 20, the space between the digit is also considered.
Space.
But
the speed of light only, na?
The space is also considered. So
Space will not reduce your speed. Space
Sir,
will
mic and-
travel at the speed of light.
the speed is not reduced, but it takes
But
the
the
space
question is
also
why
as,
it is slow. That is the question.
it takes the space also as a character of the hex file. It takes all the spaces of.
The question is it slow? If slow, why?
Yes, sir. This
Because of space.
space is extra.
Speed of light. Space.
It's actually what happens when we send 30, 20, 30, 20. These are the hex values which we need to send. And so it will take three different separately 0.
Should a wireless cannot consider it only a hex file.
Sir, it is only the difference of data type which we are sending.
Why should you defer your data just because it is wireless?
Sir, if in case the data type match is not an issue and the conversion is not needed,
Not issue.
there is not much.
Sir, na? So you have to yourself question that why did you go into ASCII? Why should it not work as a data this thing? That has to.
So currently whatever we are using, there we need to convert the data.
What?
So the text box fetches the values as character and it converts them. It takes their ASCII
But
value.
it has to nothing to do with the wireless.
Yes, sir.
Maybe something ready-made you use.
No, sir.
Ready-made means by ready-made the protocol, ready-made protocol, not
Yes.
the
Only the functionality gets added so that
This does not get added because of wireless. So your answer is wireless and is no difference.
Yes, sir.
In your setup, your projector, you use whatever is available. But you see, can you use the same thing which wire thing is doing?
Yes, sir.
These questions, what it is clear is the boundary points you are not clear. Like when you calculate efficiency, when you calculate what you should include, processing should be included or not. So those boundaries you are not clear. Second thing what I observed is in terms of understanding of technologies. Do you have a clear understanding of what is wireless, what is OTA, what is Wi-Fi? I saw that you have used these three words as you like. Are you clear? For example, your title itself, wireless OTA. I don't know if that's appropriate.
Here is always wireless.
Are you clear about what these three things are? Wireless technology, what is OTA, how it is different, what is Wi-Fi? Try to understand some of those concepts to actually,
Sorry, before you actually delve a little more deeper into it. That's just a suggestion. Yeah?
With learning, attempt is really appreciated. If you make a mistake, you will never realize.
Exactly.
So, from that point of view, we are.
So much. Now moving ahead with our next session and next keynote speech is by Mr. Vishal Deshpande sir. He is Principal Programmer, Program Director at Ericsson India. So sir is pursuing PhD in SDA in optical fiber from NMU Jalgaon. He has done MS in software systems specializing in computer from BITS Pilani and a BE in electronics and telecommunications from Pune University. He boasts 20 years of IT industry experience, having held and L&T technology services. He excels in managing and setting up R&D units and pioneering innovative technologies like cloud computing, AI, and microservices. In academia, he contributes actively, pursuing research in advanced networking, publishing papers, and delivering speeches at international conferences. He startup ecosystems, guiding ventures, and fostering innovations. I welcome you, sir. Now I request Dr. Pranati Maneman, Head Department of Electronics and Telecommunication, to felicitate Professor Deshpande sir. Sorry, Mr. Deshpande sir. Thank you, ma'am. Sir, I request Mr. Vishal Deshpande sir to kindly give his talk on pervasive computing. Thank you.
All set. Thank you. So, respected Dr. Vaidya sir, Dr. Jain sir, HOD ma'am, Nabega ma'am, all the members of faculty members of UNESCO, and all the fellow research scholars, a very good afternoon. There's a difficult task in front of me. There are about 60 lions who are hungry, right? They were supposed to get their lunch break half an hour back. And there is a guy standing here in front of you who plans to talk 30 minutes of rigorous technology stuff. How many of you are volunteering to hear that? Zero hands. Did I expect anything else? No, I did not. Oh, there are 2-3 hands. Guys, you will be beaten by all other 50 people outside, I'm telling you. Okay, so there is a challenge in front of me, right? Like Subhash Chandra Bose said, "Tu mujhe khoon do, main tumhe azadi dunga." I will not give you azadi from this half an hour. But what I will do is, if you ensure that you listen to what I am speaking, okay, and look at some of the architectural diagrams or the flow diagrams, I'm 100% guaranteeing you that you will definitely take something very important
advanced technologies of the day. This will certainly help you in terms of understanding as well as correlating it with the future as well as what is happening in the industry. So now how many of you are volunteering to hear what I am saying? Oh, I have so many hands up. Oh, including the faculty members. I appreciate it. So, first of all, thank you so much for giving me this opportunity to discuss with you. For me, it's always a pleasure to come in front and to meet people from NESCO. I really enjoy it. I mean, I'm not saying it because many people know me so well. I'm very upfront when it comes to saying it. Moving to the topic of pervasive computing, right? What we do is, usually we like to understand something which is not what is happening today, but something which will happen tomorrow. Why? Because if you want to create a solid base for yourself for future, you create the future itself. That is what Abraham Lincoln said. Going to the next slide. I can control it, right? No, this is PDF. I think you'll have to go. Thank you. A very quick agenda or context setting. We'll talk about definition. Why? Because we are all science students. Without definition, we don't touch the topic. So we'll talk about definition. Then we will talk about history and evolution, just to understand how technology came into being, what were the different milestones and steps which included or involved this technology. Then we will move to the specific of technology, where we will talk about principles of pervasive computing. We will also talk about key characteristics of pervasive computing, so that you know what is pervasive, what is not pervasive, right? And then we will move into the research areas and which are the technologies involved. Because in a way, it's like a basket. Pervasive computing is not one technology, it is a basket of technologies. So you will come to know what you should consider in terms of research areas or what are the different technologies involved in this. Then we will very briefly discuss about technology trend. Considering this 1:30 time frame and the reduction of total discussion, I will not speak about technology trend to a greater extent. We will talk about a quick technical flow. I wanted to call that as an architectural flow, but instead of that, because I am showing architecture up front, I will call it as a request response flow. Then we will also see a technology has challenges when it is comparatively new, when it is novel technology. I will speak about some of the technology challenges faced by pervasive computing. Then market size and some other data, probably depending upon the amount of time remaining, I will cover or I will skip that. Most important for each one of you is to understand what are the opportunities for you with pervasive computing. I think I have to hold this too close to my mouth. Okay, am I otherwise audible till the last person if they are interested in hearing me? Yes. I am audible, thank you. So definition. Let's define the word pervasive first, right? Something that is spread throughout so thoroughly as to be seen or felt everywhere, that is pervasive. The word pervasive itself is defined here. Coming to the second part of the definition, as you can see, I have put two different definitions of pervasive computing. The middle is what I like most, and I will tell you why I like that. It has the elements, for example, the integration of computing technology into everyday objects. This is extremely important part. When we say something has become pervasive, it has to go into your day-to-day, everyday objects. Environments and enabling seamless communication. It should not be a forced communication. You are pushing some data, you are asking, demanding some data. No, it should be seamless communication with data processing, of course, because you need to have intelligence built into it. You need to have decision making built into it. Integration without, this is the last and very important part, without explicit user intervention. Pervasive computing, the boundaries are clarified when you say that something is pervasively inbuilt into your environment, day-to-day object, and it is able to do its own data processing without any external user intervention, then you call that as pervasive computing. The architectural part is shown on the right-hand side, where I have kind of shown the foundation of pervasive computing. There are three very important solid building blocks which create the pervasive computing process. First of all, it's the embedded computing. It's very clear definition itself that embedded computing is an integral part of pervasive computing because it brings the intelligence, it brings the processing to the everyday objects. Now, we have some friends here who were who were wanting to put chips and sensors inside the baby's diapers also. That is how pervasive it can get. So embedded computing. The second part is almost every project that I heard or every paper that I was hearing since morning was talking about sensors. This is what IoT has done to us. We'll talk about that in a couple of other slides, but everywhere, sensors everywhere is what also helps you getting near to the pervasive part of it. The third and very important part, and which will also appear in the challenge slide, is low power and the low cost connectivity. It's not only connectivity. We spoke about wireless, we spoke about multitudes of other things, but here we are emphasizing as a building block of pervasive computing on the low cost and low power connectivity part of it. Connectivity, sensors, and embedded computing. These are the three fundamental blocks. Next, please. A little bit of a history, right? Everybody likes to watch Hollywood movies, so a little bit of history over here. In before I start on the history part, I just wanted to clear your mind, right? Something called as desktop computing, something called as mobile computing, something called as grid computing, so on and so forth. All these are different technologies. The only technology is ubiquitous computing. So ubiquitous computing has I will explain later. Out of this, is there any cloud computing is a very big buzzword? Has anybody heard anything XYZ computing which is not captured here? Machine computing, this computing. Yeah, please. Quantum computing? Okay, fine. Because of engineering part, I have not considered that. That goes into fundamental physics. Right? Okay. Coming back, but I'll definitely try. I've kept one box blank for you. I'll include that part next time. Thanks for that. So how it happened or how it started is in 1988, Mark Rizal, he created an ecosystem where he tried to replace these stationary kind of items or office supplies. Let's not call it stationary, office supply items. So what he did is he brought in tabs, pads, and other handheld devices which were doing the exact work which otherwise the office supplies were doing, like taking notes. Instead of post-it, he brought in tabs. Okay, so on post-it, you will not know where the location is, but when you are taking a note on tab, you know that this is the location where you are taking. So there were two things which Mark Rizal did in 1988, which was comparatively, making the industry or making the technology go ahead. First, he brought in the concept of location awareness, and second, he brought in the pressure screens or the screens which I'm not calling it as touch screen because it was not popularly called as touch screen. It was called as a pressure screens. So that is what that is what happened in. Oops. Is that an indication for me to wrap up? Okay. In 1988, Mark Rizal did that. So this was something like a soft starting for the pervasive computing industry. Then in 1992 or 93, Olivetti Research Lab in England, what they did is they replaced the iCards by something called as on-chip iCard. So the iCards were having chip inbuilt into it. That is where the pervasive computing started getting into our lives, into our probably skills, right? So coming to this point, what Olivetti Lab did is, with the on-chip computer, there were 2-3 points which were achieved. First of all, the employee access and authentication was by default achieved, right? Because there was an access identity management which was in place. Second thing, wherever the employee moves, obviously that card was moving, and we will know that this employee has taken this decision or this employee has completed this activity at this location. So again, location, but with a little bit of more information. And what is that information? What are the other elements or gadgets or equipments which are around? So this person has taken he or she has taken a printout from first floor printer instead of third floor printer, which means you can correlate some of that data. So location awareness along with the proximity to rest of the gadgets or rest of the equipments. That was what was the second and third point. The word pervasive was not so much good. It's only around 98 when IBM Lab created their own, their own unit or portfolio called as pervasive computing unit. That is when the word pervasive became a little more so-called pervasive, or that is when it became more popular. So this is a little bit of a history. I'll take a 10-second pause. Anybody any question on the pervasive part of it, or the history part of it, definition part of it? No? Let's go to the next one. As I promised to you, the principles of pervasive. Here I am showing a two-dimensional view of pervasive computing. What it is and what it is not. So anything, when we call pervasive computing, these are some of the expectations. It should be anytime and anywhere. It should not be. You should not be away from pervasive computing. The whole purpose is lost. So it should be available anytime and anywhere. That's the most important aspect. In terms of variety of devices, you should not limit the concept of pervasive computing only to desktop or only to mobile devices. It should be capable of handling UX, which is a lot of different types of screens and devices. So that's why any type of device, any type of network, in the sense, you should not depend only on Ethernet. You should not depend on. How many of you have heard IoT edge access? Excellent. So essentially, edge access brings in that concept of doing some things at the edge, which means that even that network is not beyond the reach of pervasive computing. Any data. This is an important part. You cannot say that my pervasive computing deals only chatbot discussions, and that's why when you are, especially the group sitting out here, if you are on internet chatting with somebody, please remember, even if you are chatting with a chat box, because of pervasive computing or because of sniffing of the data, your privacy is affected. Be very careful on some of these aspects. Of course, that's not a challenge or problem of a pervasive computing. That is a different reason behind hacking your data. So that's on one dimension, that it is anytime, anywhere, and any data. On the second dimension, there are key concepts of which go into the principle of pervasive computing. The decentralization. You're not taking decisions centrally. I spoke about IoT edge access. The decisions need not be taken centrally because the system is pervasive. Action is not centrally taken by a brain. The reflex action is there and then itself. On the very similar lines, the decentralization of decision making happens in the. I am going slow on this slide is because this is very important for understand what comes under pervasive computing and what is outside of pervasive computing. The diversification, which is essentially multitudes of devices, multitudes of technologies, multitudes of integration, which means that how you are connecting and how you are enabling that connectivity and keeping that alive throughout. It is essential that your pervasive computing, information pieces or units should always be connected. If not, whenever they come into a connection or connectivity, they should be able to share the historic data also. The simplicity is extremely important. Why simplicity is important? Any guesses? Reasons? Because it is pervasive, it is coming to your and my life. Right? Take an example of a blood sugar monitor. If it is very complex, you will not be able to put it just under your shirt or like that, right? So it has to be very simple in terms of its form factor, in terms of its usage. In the principles of the technology, now let's look at the characteristics. I'll not spend too much of time on this. In order to save some time, what I'll do is I'll just show it here. I'll allow you to read. Is everybody able to read this? I hope the font is big enough. So these are the characteristics of pervasive computing. I personally like to focus on character number 2, which is ultra fast computing capability, because you are having enormous number of devices here. So ultra fast computing capability is required. 08, which is the low power consumption and battery power. In the next slides also. I'll wait 10 seconds for you to finish this. As we saw in the definition, why definition was important or why it was important to start with that definition is you point to 5 and 9. They are directly coming from the definition. So this is how
pervasive computing has come into existence. I can move to the next one? Sure, thank you. Please. Okay, now what are the research areas? See, we have 58 people who are dedicating their time to research. They are research scholars, they have done some work, they have tried analyzing things. But then they need to know which are the areas and how those areas are looked at by research communities or standards bodies in pervasive computing aspects. There are three essential areas, right? Core area, which is the fundamental of pervasive computing, which is your tower number. Then there are applied areas where you use those core areas and you create some of the applications around it. Okay, they are still pervasive computing, they are still related to core, but they are indirectly, overarching the core. Then the third tower, which is not in the pervasive computing or computing space per se, but they are separate type of applications or separate type of sectors which are making the use of pervasive computing to take their sectors or their fields ahead. So that's your third, which is the lateral part. The word here is multidisciplinary aspects. All the multidisciplinary aspects are coming into play here. Sports industry has nothing to do with pervasive computing. If you put the variables, or the minute you put that sports person in front of some cameras or in front of some sensors, every action that sports person takes is coming under the application of pervasive computing. So these are the human-machine interfaces or machine-to-machine interfaces, additional areas of research. Reason for showing these three different categories is when you people are doing research, and this area is growing quite rapidly. Many of you will find that you are doing some research related, if not within this area. That's why I am trying to show you the bifurcation. More and more core research if you are doing, that will give you more satisfaction. In the core field, I am sure everybody knows image processing, signal processing, the embedded part, the power electronics and electronic devices are coming under this. Internet of Things, I think almost every paper spoke about sensors and IoT. Again, I have a reservation. There are reasons why I call something as IoT. Just because there are sensors and you are fetching the data and putting it on mobile app, that does not make something as IoT. But today's topic is not IoT, I will not speak much about it. Wireless communication systems are definitely an integral part. As we saw in the first architecture, one of the fundamental blocks it was wireless connectivity or the connectivity itself. Again, applied and lateral, we spoke about. Okay. Am I rushing too much?
No.
No? Nobody is saying yes or no. Am I okay? No? No? We can? Yes?
Okay, so you are fine.
Oh, okay, I'm fine. Alright. So let's move. Okay, as I promised, we'll not talk in detail about technology trends. Why I wanted to show you this slide again, just like last slide, it will define what area you should pick up or what area is growing faster than rest of the areas. That will channelize your thoughts, that will channelize your efforts into different research center or into your disciplines that you want to pursue for your ME, PhD and so on and so forth. We saw that hardware is one of the integral part of pervasive computing by architecture and definition. Hardware is growing very fast. Usually when a new service is big and then later hardware becomes a very small part, services takes the bigger part, correct? Same thing happened we saw in IoT, hardware gets commoditized very fast. Fortunately for pervasive computing, everything is driven by hardware, because of which even now after so many years of existence, pervasive computing has 47.1% of presence, 43.7% of presence of hardware technology. Which means it is very hardware intensive technology. Is it a good news for electronic students? Please say yes or no. Yes. Thank you. Wireless connectivity, again, we saw that the fundamental element which is in the fundamental block is connectivity, low power connectivity. We just heard from some friends about OTA, over the air. Some of these technologies related to connectivity which are emerging and which are proliferating, I would say, are really going to encompass more and more aspects of wireless connectivity. You will be very surprised to know, in fact, I was saw that 81.3% share in the wireless wireless space or in the connectivity space is eaten up by wireless connectivity, which means everything is non-connected from the perspective of hardwiring, which is a very good thing for you because most of you like microwave, wireless, signal, this and that. Everybody who is from TC, telecommunication branch, they have this wireless as their favorite topic. Now that we have seen the bottom layer of hardware, the next layer of wireless, let's look at the application side of it. What is industry using pervasive computing for? Mainly three areas: asset tracking and management, and supply chain management, which is core, as Jen sir have mentioned. These are the core of any industry. You name it, any big manufacturer. These three fundamental aspects: asset tracking, what is your inventory? So these areas are so core to industry's operation, and they are being used, or they are the application users of pervasive computing as a technology. More than 60% in enterprises are using it. Not only that, as I just said a few minutes back, and as some of our friends presented, there are new sectors. Fields are coming which were not thought about in the past. Sports is one such field where it was not thought that technology can make the sports person better. But there are a lot of checks and balances, sensors, and in-body chips which are being put to make the sports person more and more efficient. Which are the new industry segments mentioned? Smart home, the cradle part of it, or the baby, cradle part of it. I would put it into the home, smart home kind of technologies. And building is automated, and most of the Western world, especially the parking areas, are fully automated. Environmental monitoring, sustainability initiatives, because everything we are planning and hoping to go to net, not for ourselves but for the next generations. Remote patient monitoring and overall health services. The telehealth is another big part. Remote patient monitoring, there are about, so if I start talking about it, I can speak for about 6 hours at length only about healthcare services which uses pervasive computing. That is how important this area is for the healthcare industry. Edutech and sports. Sports I spoke about. Edutech, essentially how the students are performing. Are they blinking too much when they are answering some question? Are they copying from some other internet or some other phone when they are answering the quizzes and things like that? There's a lot of application on the Edutech side for pervasive computing. I was intending to show this and explain this in detail. The challenge is that I cannot right now, but there are two very important points which I would like to mention. Please see that irrespective of any device, there is a funneling of the request that is being controlled, and then there is a way for device manager to find out what type of device or what type of connectivity, what is the source of the request, and accordingly route the request. So there is an aggregation and there is a routing or separation of requests. Another very useful thing to very briefly quickly mention here is after 5 on the command once you understand that this is a common request, you are not processing it per device base, because that will cause a lot of inefficiencies. You are actually routing it with your common response engine. So two important things: aggregation and distribution. That's one part to look at it. And second, response engine is anyway going to commonly take care of your requests. Any question on this? I've not spoken too much. I'm sorry about it. We are running a little late. No questions? If you have any questions, please next. Now comes the technology challenge. How are we doing on time? How much time we have consumed? 20? No, nobody's counting. So okay, fine. Let's very quickly go over this. See, I have been saying since the beginning that I will cover this in the last slide during challenges. 5 minutes more, okay, or 5 hours more. 5 minutes. Right. So here the pain points are being chalked out, right? Why you should study pervasive computing a little more? Reasons are here. There are a lot of things which science and engineering is waiting for you to solve. These are the challenges. Can you do something about these challenges? Which are those challenges? So we all know, right? Our older phones, they were bulky, the newer phones are smarter, smaller. So every generation, after 18 months, every generation, there are good advantages in the next generation. There's no end to it. But it's very difficult to manage with a very small form factor, a small size, with the weight part being more lighter, because you have to put those chips into your body or put those chips into, say, things like chair or anywhere for that matter. So lighter and have a longer battery life. Are investigating IoT. Can you tell me what is the battery life being talked about for some of the IoT devices? Correct answer, can go for lunch very quick. Anybody? What is the battery life in case of IoT sensors or devices? You are the researchers, huh? People are talking about minimum 50 years of life, which means once you have that device, say, put into fab or put into some industrial equipment, for 50 years the battery will continue. That is the aspiration, that is the target people are talking about. Have we reached there? No. That is something which you as researchers need to help achieve. And unfortunately, what has happened is there are experimental setups where some of these things are done, but then it compromises your computing power. It compromises your capability to speed up the computing. We know processing cannot be compromised in pervasive computing. We saw that as a principle, right? So something is being compromised, that is not the right solution. Coming to the second part, user intent. This is that nervous system. So which means what the user wants or what the user is thinking, technology should also consider that user intent part of this. This is completely new. I'm not sure if anybody has heard this. Take an example that you're browsing some website. For example, you want to see what is the value of such and such share today, and it's going round and round, and you're not getting the. In such case, what should happen? Should you be shown a cached data of previous day or previous hour? Should you be getting a message saying that your connectivity is bad, please switch to another connectivity? Or you should be given some other option of some other website or some other place where the connectivity appears to be better. So there are multiple options depending upon the user intent. Accordingly, the decision has to be taken or the priority has to be lifted. This part is not common with any of the other that you have seen. The prioritization, the user intent aspect, very important and critical because it is a pervasive part of it. Because it is so perturbed or so much inside your system that you need to know why you are doing something, and technology can benefit by that. The adoption strategy, again, a very similar point but on a slightly different angle. As a technology, there is a big challenge in understanding what we need to adapt to. There are multiple resources always fighting for each other's stake, right? So it's like IPL, because it's IPL season. I'll give an example of IPL. It's like an IPL season where you have only 11 players that you can take in the team. You cannot have all 11 players as your as your bowlers or as your batsmen or specialists, right? So you need to have a mix and match. That is this adaptability challenge. There are multiple resources which are fighting for each other. You need to create a tuned, balanced approach. Our friend was showing, when you were presenting banking part of it, you were showing that for this type of PCB use this material, for this type of PCB use this material. That type of cognizance has to come in. That type of adaptability has to come in. I'm not taking PCB as an example here. Coming to the next part, cooperation again amongst information sources, security, privacy, so on and so forth. A lot of things. Integration. I want IP to be mine. I don't want to share it with technology slows down. Engineers' job is to find workable solution. That is where your role is. How can you make some of these things workable in spite of challenges related to varying information sources? I'll take an example of the liability is there. Something is
is very accurate, but it is inaccessible. You cannot put the output of that system. So take an example, you are monitoring weather system. You are data, but you are not able to feed that data back into the dam management or water resource management. So if there is no accessibility, what will you? So information sources and usage or application of that information for pervasive computing, you need to build those bridges. The next part is information security. So much talked about it, so very important in any aspect of technology. None of you would like your phone to be hacked. None of you would like your laptops to be stolen, or there should be any privacy invasion on your laptop. Same goes with pervasive. It in fact is more critical because pervasive computing comes very close to normal day-to-day objects and environment. We saw it in the definition. Because it comes so close to the normal day-to-day object, security becomes even more 2 times higher important. These are the technology challenges. I think nobody is going to ask questions, so I will not take a call. If you have, just raise hand. Next. I was trying to show the industry data from the perspective of exciting you, making you encouraged to spend good amount of time and knowledge in this field. This field is burgeoning. Okay, I think nobody has seen and I think Dr. Vaidya sir as well as Dr. Jain sir will agree with me. When we look at the CAGR, does anybody know the full form of CAGR except for the gentleman? Yes, please. Good, I'm happy. Compound annualized growth rate. Yes. So it means that if I look at 10 years and if I average it out, what is the annual growth rate that the industry or the sector is showing? 21%. There are many good and nice technologies, but usually even most fancy technologies, the CAGR does not go beyond 11-12%. 21% CAGR over the 10 to 11 years horizon is phenomenal. Today, the technology is roughly below $1 billion, which is about 670 billion or so, 670 to 800 billion. And there is a guaranteed view of that technology reaching $4.5 billion. What should come into your mind? That means a lot of research opportunities, a lot of job opportunities, a lot of other good things lined up for you in this technology. The second aspect, which I have already covered, but I will like to show it to you here. Typically what happens is hardware becomes smaller part over the period of time. Here, hardware is still 43.7% even in the year 2033, which means the industry is growing, the technology is growing, and the presence of hardware is growing. Who is going to benefit out of this hardware presence? Electronics engineers, correct? Right? So that's why this is important for you. We'll move to the next slide. Just before I go to that, so on the previous slide, an important aspect, right? Many people want IT and computer jobs because they can go to US. Please look at the last line here. Most of the consumption of pervasive computing and research are happening in US. Out of 670 million for 2023, close to 50%, 48% is consumed by US. Not only that, the forecast is that the biggest market, which means the opportunities are definitely going to be more in those types of. At the same time, please keep a caution. As actually told all of us, when you are going somewhere, please find your purpose. Do not go blindly just because your friend is going, right? Next. So demand fluctuation in industry and branches. This is towards the concluding part. Why I have kept this slide is to again kind of bring a cheer on your faces, right? Because what we have seen is there was a time when in India electronics industry was booming. Bangalore was called as Silicon Valley of India. The focus on electronics became less. Similarly, before that, when India was building bridges and dams and whatnot and roads, infrastructure, civil engineering was in boom. Then we saw civil engineering going down, and now again we are seeing civil engineering picking up. We saw mechanical engineering was phenomenal. Anybody in Pune, they will definitely take the branch mechanical engineering. There was a time when IT kind of stole the thunder. Engineer became subdued, mechanical engineering became subdued. There were a lot of news pieces because of 2007, 2008. Capital was very low or unavailable, because of which mechanical industry showed a labor of some. But now with electronic vehicles, with a lot of other research, even mechanical industry is doing. What this whole thing means is every industry will have demand fluctuation. Do not think that I'm in a wrong industry or I chose the wrong branch. Remember that electronics is coming up in a big way. I'm sure all of you have heard the news articles related to how India is setting up a lot of semiconductor. Right? How many of you have heard that? Still 40-50%, but yeah, essentially India is becoming again, or India is aiming to become better than China in terms of creation of fabs and creation of semiconductor devices. So every technology has a cycle. If something has gone up now, there's a possibility that it may go a little down in 10 years. If something has gone down, it will definitely come up. So be pursuant of what you are doing and what are your interest areas and what you are wanting to do. Things will pan out for you as well. Next and the last, I spoke about opportunities. There was a time when people used to talk only about ICT. Anybody full form of ICT? Please. Perfect. You people know everything. Why am I standing here? Thanks for that. Now, what people are calling is not just ICT, it is EICT, which means Electronics, Information, Communication Technology. So that is a change that has come. There are a lot of government policies like DLI, which is supporting electronics industry. A lot of good things are going to happen for you. Hardware, I say, for pervasive computing is increasing. The last part, there are a lot of technology companies which are coming to India. In this particular forum, I can say this statement, probably outside people will debate with me, but or a supplementary branch has become a fundamental branch. Why fundamental? Because pervasive computing. Or because technologies like not only pervasive computing, technologies like pervasive computing, every field has electronics inbuilt. I'll ask you, last couple of 2-3 minutes more. I have no. No? Okay, but still I'll ask this question because that's to encourage you. The way some of you did this, yes, how our industry is growing for electronics engineering. That's why I thought I'll take these 2 minutes extra any which way. If you go to mechanical industry, other than mechanical engineer, which all other engineers will be accepted? Answer fast, you will be released fast. Electronics, mechatronics, right? Mechatronics is a combination. If you go to computer industry, other than IT or computer engineer, which other engineers will be easily accepted? Hardware. Electronics, hardware, correct? If you go to civil industry, where some of these smart cities, smart automation things are being created, which other engineers will be accepted other than civil engineers? If you go to electronics industry, which basically will be accepted? Okay, so you are going to find yourself everywhere in electronics industry, that's why best wishes to you. At the same time, do not lose your focus on research. Do not lose your focus on innovation. Okay, with that message, I want to thank everyone here for listening to me patiently and not being hungry lions in front of me. Thank you.
Thank you so much, sir. Ourselves as pervasive. I hope our engineers will also find themselves as per their choice.
Actually, I'm sorry. I also felt like a little bit cheated on time. I missed the second part, and I just wanted to. I felt like really adding. Otherwise, I won't have sense of fulfillment, to be honest. What you mentioned about China at the end, I definitely wanted that one point which I missed because of the shortage of time. And the second point was most commonly asked question I have is which field, which branch, which stream has more scope, sir? So you touched upon that topic too. Thank you so much. Also, he mentioned a very important point which I had to cover in my when the downtrend of mechanical engineering was having, and when it comes to curriculum, when I say outcome-based education, remember, most of the mechanical engineers, most of the civil engineers went to US during that. Some friends and colleagues know through distant like relatives, they completed their masters in IT. Believe me or not. But that's what I was trying to touch upon repeatedly. So bound, we are so tied up in the curriculum and our credentials that you get filtered. Doesn't happen in that part of the world, in that continent. You could have done a mechanical engineering, but you could pursue your masters in IT, in computers. That's what many people did, switch to IT after Y2K. So that was one thing which is the flexibility, the country, the land, the Western nations adopt, and they are definitely advancing. Second thing I definitely want to touch upon China is, as I have seen it from the other side of the world, India is trusted well on their technical competence. Cutting edge, the upper edge, we have in the third world nation, including China. The most important thing which I wanted to touch at the end was communication. Improve your communication. I see spoken English classes at every nook and corner now. But unfortunately, again, as I said, I don't mean to offend anybody. They're doing little good to this society. They are the kids in convent school, CBSE. If I ask them to introduce themselves, the secondary school is unable to speak 3 lines about himself or her. That makes me really sad. Leaves me with tears. Like, we are looked upon. We have scientists all over, we have doctors everywhere, we have everything. But when it comes to communication, we try to become skeptical, we are not able to express ourselves. That's the only thing we are lacking. And when it comes to China, we are way much ahead. You know that I would definitely share this something humorous with you. When I was with Tier 1 for General Motors, sir, which was it? When I was with Tier 1 with General Motors, you know what? Our harness cable assemblies would be way much costly than sending it to vendors abroad. And what we would say is, if you want to buy a Chinese car, you buy not one car, you buy 2 cars and always tow one with you. So one will break down, you take the second one with you. And the second one was, you turn your left indicator on. And flexible and well-rounded for Chinese drivers because they drive always the opposite side.
Adding your views further to the Reshma speech. Now I announce a lunch break for 30 minutes. So we'll gather here at 2:40 sharp so that we can join in session. Thank you. The lunch arrangements are made outside. Good afternoon all. As we are resuming our post-lunch session, we'll begin our post-lunch session with paper presentation. So I invite Vaibhav Kurbe, Savinay Kapre, Abhishek Chikane, Manit Kumar Dhanvijay to present advanced firefighting robot for fire handling in construction.
थोड़ा सा दिया
We are from SYMPOSIUM Skills and Professional University. Myself, Savinay Kapare. This is my teammates. We are here to present our presentation on automated firefighting truck in inaccessible area, guided by our director Dr. Manit Kumar. Some of these points in our presentation, like introduction part, literature review, and materials and method, result and discussion, conclusion and reference. So our purpose of the project is fire safety in the area like a nuclear power plant and oil rigs. And then materials and methods covered by Abhishek.
Before I can start, I'll just revise something. The introduction part, this small introduction part. The fire safety is something a crucial job role right now. There is a lot of research and development going on in regard, but it's still under development. We can't say it is 100% fire. We can't say we're 100% fire safety proof or something like that. The purpose of this project is for, we can say, the inaccessible areas such as nuclear power plants, oil rigs, different locations where the human interaction is very low, but fire risk is more. To prevent that at base level, like small fire cracks out, and we can stop that. If human is not there, the robot can stop it. So we are focusing on that thing. That is our purpose of treatment. For literature review, we can say first thing, all these papers, these are the 7 papers we have referred. I'm just going to chop it down for 5. These 5 papers mostly focuses on the robots which are mobile operated, or it may be a robot which is having a specific range, which is not mobile, which is going to cover only specific area, not a large amount of area or this amount of, example, this room. If we keep a robot over there, it is not going to prevent the fire on that end. So it is not a mobile robot, or if it is a mobile robot, then it is not an autonomous robot. So we are focusing on autonomous as well as the we can say different areas require different selection criteria or modular design. So for methods and material, I can say that we are focusing on 3 elements. One is the modular design. Second is the system electronic sensor integration. Third is the these 3 elements is crucial for our project, which can be changed according to the industry needs, which can be changed according to the requirements of the fire safety or fire prevention. So I'll elaborate in small words. Like modular, as we can see, modular design is important because if in an industry for oil rigs we can't make a robot for moving like a rower or something like that. That robot should entry robot or something a leg robot we can say. So depending on the requirement, it should be flexible and as per need we should modify it or customize it on our need. That is why we are focusing on modular design. Second, sensor integration. Sensor integration, different types of fire can be detected by different types of sensors. Like if we see most of the IoT project or different small projects, they mostly use flame sensor, which has limitation of 40 centimeter of flame detection. But in bigger industry, they use thermal cameras, which has ranging from 10 meters to 50 meters to 100 meters. It is not having any limitation as requirement in thermal cameras can be used for vast purpose, but the cost is much. So mostly people avoid having thermal cameras. They use multiple sensors in multiple floor areas. That is their main purpose for fire detection. Like smoke alarms and everything, it is placed in every we can say area or something like that. Distance पे रखते हैं because flame detection for specific areas only detected, not for all areas covered. तो कुछ ना कुछ blind spot रहेगा, but thermal detection camera के लिए बहुत कम रहता है, even ultraviolet sensors के लिए. So next is autonomous capabilities. This robot can have autonomous capabilities to example. अगर कभी फायर लगती है एंड कुछ एलर्ट्स वगैरह होता है, सो वी कैन मेक श्योर कि अगर कोई बंदा ऐसे कि मतलब रोबोट जो है खुद सोच के मतलब डिसीजन लेना चाहिए कि समवन इज इन फ्रंट ऑफ मी और समथिंग इज तो ऑब्जेक्ट डिटेक्शन शुड बी देयर लाइक फॉर एजीवीज वी कैन से ऑटोमेटेड गाइडेड व्हीकल्स कि अगर बीच में कोई बंदा आता तो गाड़ी रुक जाती है या तो ओवरटेक करके जाती है. So mostly as a decision making is must for the robots. So it will harm someone or something which can cost us some great amount. Next, for materials and method, I'll just cover the material part. We do have different sections for materials. First section we can say mechanical design and fabrication. For mechanical design and fabrication, we can say that we are using. First thing, we are focusing on chassis. Chassis can be designed as per the requirement. Some will require kind of chassis for tank. Some will require a car chassis model. Some will require a robot chassis model. So the chassis will change as per the need and requirement. Chassis, after chassis, we can focus on outer body. The outer body is the material which is going to cover the robot, which can avoid the flame or heat to disturb the circuit or something which is inside, like water tanks to melt or something like that. So outer body is a crucial part. The materials section is the must in that. Next is water tank. In water tank, we focus on like currently we are in prototype stage, and we have focused to make it of ABS material for small mobile robot, which we can say that water tank will be of ABS material. Next. The nozzles. Nozzles is the crucial part of the mechanical system. Without nozzles, the pressure can't be focused, or if the water pressure is not there, then the fire, the concentration of fire may not get reduced. Next, computing hardware. We have focused on computing hardware for Arduino Mega right now, but it can be flexible. We can use Raspberry Pi, or we can use a mobile core or something like that. Like actual smartphone, we can use that also, but on basis of requirement. Next, electronic components. Right now we have focused on a tank type small mobile robot which do have Johnson motors, electronic components as flame sensors, then wheels, buck converters and everything. Next part is like for making our project we have used multiple softwares like Autodesk Inventor, Multisim, then Arduino ID actually. Arduino ID and for simulation multiple softwares we have used like we even used Arduino Mega. We can't purchase it on first and directly code it. So for package simulation purpose we have done it Tinkercad first. Then this is the working of the project. The working of the project as we see, the fire location will be detected by the thermal cameras, and the ultrasonic sensor will always look for the obstacle in between us. Then the Arduino Mecha will process the inputs and the supply is given to Arduino Mecha for sure with battery, lithium-ion batteries. Then the robot will try to move from one part to the other part by using this elements such as the DC motor for the direction of the flame which we have to extinguish, and the water pump to pump the water. Then the bulk converter is to control the output for the wheels, which is Johnson motors, which will provide the power to it. Next, last.
Tested it like we have set us a small fire, and the prototype has gone there, and it is extinguished the fire according to the area and where the fire is, and it is set on the fire and it is extinguished. For the we have like for in the prototype stage, the maximum weight for now is 6 kg, but in the some final stage we will increase the capacity of the range. The sensor which we are using now has limit maximum range, but for the large range we can use which has 50 to 100 meters capacity. Like there are prototype is customizable. For we can use one type of robot. For oil rigs we can use another type of robot. So it vast and major different types of capabilities which can, and it is vastly customizable. For reference. These are the reference we have taken, and thank you.
Mike.
So, the area that you have chosen, the application is quite useful. Can you just describe out of three of you who did what individual contributions?
Sir, actually, I am looking for the Arduino part. Electronics parts like motors and actuators.
Okay. Who gave you the requirements for this?
So
Like 50 centimeter for,
So actually, we prefer the data sheet for the flexes.
Oh, okay. So
And for the thermal cameras, actually, we go through the internet for other.
Actually, sir, we have tried to research on internet, but currently, if we go to make projects or something like that, the flame sensors which we get for making projects is the maximum range. But industrial electronics use there, that may vary, but the cost will also vary. So right now we are trying to make a base prototype model, and we are in fabrication simulator.
Understood. So basically, you have assumed some of the requirements.
Okay.
Can you go to the next slide, ma'am? Just so good. As I said, no. Where they were showing literature review. So yeah, one before. Just one suggestion and request here. When you say one of the researcher, what does it mean and how you have written that person?
Actually, we have referred to a lot of research papers, and they have made the model and everything, and we have researched on.
When you say one of the researcher, Ratnesh Malik, does it mean that multiple authors are there and you are saying Ratnesh Malik is one of them?
Yeah.
I request
Actually, multiple names we can't write because
up to 6 names you can write. If there are 6 or more names, you can write et al. And for any literature review, henceforth, please do not write one of the researchers like this.
Yes, sure.
Yes. That's all from us. Thank you.
As you said, I appreciate the effort. Did you benchmark it with ABDAS, ion detection suppression system, which is widely used in industry? Also, the smoke detector, and security which comes and they do it. This can be the two alternate approaches. Did you benchmark, study these two approaches and then come to this?
Actually, we have studied it.
You have studied it.
Like for smoke detectors and everything. robot which we are planning to use, mostly कैसा रहता है sir कि जो oil rigs and everything.
My question is different. My question is just forget robot.
Yeah.
The industry has very jets, alternate functions. It's known as fire detection and suppression, FDAS. Companies are very well located in Pune also, internationally famous. They take care that that system short. The fire solution number 2, robo with more detectors, alarms are there, and the security of the train personally comes and yes. Yes.
That's not the question.
No, my question is different. Fire detection and FDAS system. See what happens. If you say I want to make a robot. Then, so these are well known. How I know in our commercial vehicles, we were thinking of FDAS system was going mandatory. Very large purpose. And this is how I study. I am still in touch with them. So fire detection and suppression FDAS system is very well used. People are happy with it. You go overseas, every room there is a smoke, even hotel room. We can start cooking, our smoke goes and we have to cover it. The security person comes who is trained in firefighting, he solves the problem. So we have to see what is it that these two solutions, after studying you say.
Sir, we have studied about inaccessible areas.
Inaccessible, you test these robots who are going without going there. If robot can access it, why a human being cannot access?
We are trying to first understand what type of fire it is and how can we extinguish it.
Even inaccessible area, stationary and putting. Okay, inaccessible area, then how robot will access it?
We can place it first.
Then place it, but somebody will go and place it. You are not accessible, you can even go with robot and testing. Can I test another robot? Like you say, I will another robot, you will take that robot, put it. Very good. See, you are done a wonderful job. Don't underestimate yourself. But you take a initiative. What people are doing today, if you go to selling this, people say, I am happy with FDAS. I am happy with it. So what is it that it cannot do, your robot does? No studying you don't see. You study it and then you see. I have no problem. But it doesn't matter. The life is not end up like, you say, study next time. That's fine.
Yes, sir.
Thank you.
If it is inaccessible, you should have thought of drone.
Testing drones, you will have
But
to
they
go.
should have thought.
Actually, launch a drone is automatic. Carrying capacity first thing for water, and second thing is like this: key drones are not
So
allowed to.
you have given a thought of it.
Yes. And also, you can even make that, but it is not visible from the beginning.
It is inaccessible.
Did you go to the exhibition there?
FDAS is the base system for inaccessible. Just put it and forget.
Yes, sir.
Thank you, ma'am.
Yes, thank you, Vaibhav, for your presentation. Now, Suraj and Yasin from MES Wadia College of Engineering to present design and implementation of varied VCD multiplier on Arctic.
My name is Fiza Sheikh and this is my project partner Yasin Sheikh. We are utterly grateful to be presenting your conference. Let us begin with our presentation. As we dwell into today's world, every nanosecond counts and multiplication is important in today's world. The project title design and implementation of basically multiplier on Arctic 7 FPGA board.
Our project is Vinculum design and implementation of a basic BCD multiplier on the design. We uses this approach because of we see the processors are ALU designs. So we efficiency is more required in the high performance of the processors, DSP processors, ALUs for getting the fast outcomes of the arithmetic. Also, this mathematic algorithm required for us in the financial and commercial calculations, like calculators and all that.
The objective of my project is to design and implement Vedic BCD multiplier using Pentium logical system. Which develops or which contributes in the area of high-speed arithmetic operations. The core objective of our project is to design and implement conventional multipliers, 2-bit, 4-bit, and 8-bit array multipliers. Next to it, the objective is to design Vedic and BCD multiplier that simplifies multiplication process. In this, we have moving ahead with the picture data. Foundation, which is led by literature review. Fatima and Ms. Fatima and Paris Gulati has provided us thorough knowledge and insight valuables multipliers. We have used a standard methodology which is already existing in VLSI design flow. In this, the important section of design flow is architecture design, hardware description, language design, synthesis, simulation, and then implementation. And then validating all these implementation designs on RD7 PGF code. Realize two strong concepts in this that is Vedic mathematics, which includes Urdu Sutra. The Sutra is that it provides us high computational power, as well as it reduces the total number of multiplications. In Vedic mathematics, there are total 60 sutras, among which 14 sutras they have 14 sub-sutras are there, and from which 2 sutras are specially kept for multiplication process, among which we have specifically opted for the Triyaguna Sutra because of its finest accuracy. As you can see, it multiplies vertically and crosswise, and it reduces the number of multiplication steps. Its major concept or base method of our project is pendulum method. Is nothing but it's the number representation. When higher numbers like 6, 7, 8, 9, they are reduced to smaller numbers such as 4, 3, 2, 1. Also, pendulum method helps us in reducing the carry generation of product.
In design and implemented architectures. First, we designed the array multiplier, which is mainly a conventional multiplier, which we do in day-to-day life. Designed for 2-bit, 4-bit, 8-bit, and further we designed Vedic multiplication, and in which we also designed for the two. We combine two different concepts, BCD and the Vedic multiplication. In Vedic BCD multiplication, this is the 8-bit array multiplier, which is our in array that we designed this at the last of the array multiplication. The AND gates and half adders are used in the array format for adding the partial products, and in this partial products are not fully completed. The like AND gate give half partial product. For completing that partial product, we use half adders and full adders in sequence for this building block. The first is half adder and the remaining one is the full adder. Carry adder. This is the 8-bit Vedic multiplier. The Vedic multiplier, for achieving the 8-bit Vedic multiplier, firstly we design the 2-bit Vedic multiplier, next 4-bit. The one and the two different half adders. By using that 2-bit Vedic multiplier, it is a after designing of that 4-bit, we design 8-bit Vedic multiplier. It is a generic form. We can extend it up to the 64-bit by doubling of this 8-bit to 16-bit. Are requirement of the processor. In this, the partial product of the rightmost multiplier 4 into 4, its output is 8-bit. From 8-bit, we take LSB 4-bit directly to the partial product output, final partial product output. Remaining MSB bits are sent to the adder. And other three multipliers give their outputs to the adders. The leftmost adder is the 12-bit adder and the rightmost adder is the 8-bit adder. In this concept, we dividing the binary number into 4444 bit groups. For that correction of the output of the partial product of different, we require the adder circuit, in which in first adder we add 4 zeros in the MSB of, and in the second adder we add the thirdmost multiplier के आउटपुट में हम MSB में zeros ऐड करते हैं करेक्शन के लिए, और लास्ट मोस्ट केस में हम MSB में ऐड करते हैं. Next to adding of these output 12-bit and 16-bit, we give output to the final adder. It is 12-bit adder, and arranging those numbers into the final 16-bit. This is the system of the art project circuit design. It is implemented in the Xilinx Vivado. We multiplied the highest most bits is 255 multiplied by 250. For 2-bit multiplier to design the BCD multiplier, which is our main final design. We design using 2-bit Vedic. It is a basic building block for our style. Same process is done in this architecture also, but output is a binary form. And the output is also not in the correct distribution. We need 8-bit B2B converter. This is the 8-bit B2B conversion process. In this process, we shift the binary numbers to the ones, tens, hundred place, in which one place or a 10th place is greater than 5 or equals to 5. We add 3. If not, then we shift the numbers to the final proposed design of the 2-digit Vedic multiplier. In Vedic multiplier, for designing 2-digit Vedic multiplier, we use basic building blocks are 1 digit. We divided our multiplicand and multipliers of 2 digits. multiplier is of 2 digit, multiplier is also of 2 digit. Output simulation of this design. And we also implemented it on the RT7 FPGA board for testing our circuit and design. So this is the architectural diagram of our project. This is Winkler conversion. Then of the array and basic is the array multiplier. You need more delay for the longest path, and basic multiplier required less delay time for its longest path. We conclude that the basic discrete multiplier is more efficient, accurate compared to array multiplier, because binary multiplier. Binary multipliers give not accurate decimal number for the its accuracy is not that much more, but in BCD we get higher performance for the commercial and DSP processor and image processing processors.
Just for selecting this topic. Very nice topic, very useful topic. Do you people know the application, real life application where this has been implemented?
Yeah, in processes we can utilize this.
No, not can. I mean, there is a real application where this has been utilized.
So this circuit is currently not utilizing in current.
Vedic.
Yes, sir. Vedic multipliers are using because there are many researches on the Vedic multipliers done. And but for Vedic BCD multiplier, one research is done by the Fatima and Sri from the Bangalore.
Some of the supercomputers, one of the being designed in India, is actually using a very similar concept, because the data that you showed me is almost 7 to 8 times faster.
Yes.
So second part is when you create something, right, you need to put the numbers associated with that. Other than the some of the latency numbers, I didn't see too many. Please do that. For example, when you are having a multiplication of 2 multiplied by 3, how much is the cycle time versus 255 by 255, what is the cycle time? So try to bring in some of those numbers. Have you actually done that?
So when we have calculated, we actually got the reduced delay, which was in percentage of 38.7, which was reduced delay we have achieved.
Reduced delay as compared to the normal.
As compared to array multiplier, yeah.
Okay. No, what I was asking is within the same design, your smallest number versus highest number. What is the comparison? So some of those things for the resiliency you need to capture.
Yeah.
The second point is, I mean, in some of the cases you limited it to 4 bits and 8 bits. Why did you not go for a higher one? Because you have everything ready. What stopped you from going for a higher one?
We are implementing it on the FPGA board. FPGA board maximum input bits are 16.
That's why you
We have different FPGA boards, but it was currently not available to us.
Once again, choice of
Thank you so much.
Thank you, sir.
That's all from.
So I second the choice. You said DSP needs BCD.
Yes, sir.
What DSP needs BCD?
सर DSP में सर हमारे सिग्नल प्रोसेसिंग के अंदर हमारे पास पॉइंट नंबर्स भी होते हैं,
फ्लोटिंग पॉइंट बाइनरी भी होता है और BCD टू बाइनरी बाइनरी।
yes sir, but
BCD in my opinion, there's only the signals.
But sir, it helps in improving.
It is for the human interpretation. DSP is kind of automatic. BCD is for decimal system, is for human being too. That is how the Vedic people, rather than binary, they have done for BCD. Internally, human being will not ask, give me BCD. As per numerical saying, this is concerned. So, DSP you seriously consider where exactly BCD will be.
for binary numbers, always give the decimal number to the PC. The decimal number is given to the PC if they require that decimal number to the binary number. The computer is returning us the output, it is in the binary. So also there required the conversion of the binary to BCD.
BSP. In BSP, we are provided. BSP signal processing.
Yes, sir.
User will not. You are talking about user. That is correct.
Yes, sir.
You will be concerned with the BSP, which is not numerical, which will add value. So I may be wrong, but you CD is required for BSP.
Actually, we search for the Googles and so they told that the BCD is most efficient for the BCD, the BSP and email processing. We refer that.
Demos.
Okay. Yes, sir.
Okay. So DSP uses speech processing or video processing. So final outcome to the human being is a form of speech. Process speech. Process means why should I use BSP there? BSP there? That question. Whether they have in their Google. It is there the quantified metric. And when it to financial, how much delay that also needs to be quantified.
One half adder and one flatter. So that hardware comparison also you do. Okay. Number of half adders required. So simultaneous processing, how many multiplications can
Yes, now I am very much grateful to introduce to our next speaker for the next technical talk. He is Mr. Rushikesh Kulkarni, Head R&D, GIC. As Vice President of R&D and Engineering at GIC Pune, he is a and strategic planning. With a budget of $3.2 million, he adeptly oversees teams of 100 ensuring project delivery at optimal quality and within deadlines. Management and delivery management. Completed by certifications in Prince 2, CATM, CSM and PMP. Proficient in communication standards and development tools, he fosters collaboration with diverse teams driving innovations and efficiency. Throughout his career at Eton India Innovation Center, Whirlpool and Honeywell Technology Solutions, he has delivered remarkable results in growth to cost reductions and innovative solutions. Academic credentials including an MTech in MBA from SYMPOSIUM, he brings a strong foundation of knowledge and experience to his leadership roles. I request Dr. M.P. Daleman, Principal MES Wadia College Appreciation and Love. Thank you, ma'am. Thank you, sir. Now I would like to hand over the session to Mr. Rushikesh Kulkarni for a technical talk, followed by his paper for this conference. He will be delivering his talk on the cyber physical systems. Over to you, sir.
Thank you. So, I know you have gone through the multiple topics since yesterday, and when we talk about the current era where we discuss about the IoTs, then the pervasive computing system, one of the critical element which is important to be considered is the cyber physical system. So, before we get started with the topic, I wanted to know and understand what do you mean by cyber physical system? Anybody, any wild guess? It's simple, right? It's just an extension of the three words cyber physical system. So, any guess from any one of you? What is the interpretation of CPS? So, we will through the agenda, but predominantly I wanted to first spend some time onto the cyber physical system. Any product which we looked around, which is a IoT enabled product which may not be connected to internet, all of them needs to be looked from a perspective of the cyber physical system. And when I say cyber physical system, I will not go through the details of that's contribute to a predominantly into cyber physical system. All in all, I can talk about some of the examples like CPS is part of a medical, where we can see the multiple medical monitor. It is part of automotive where CPS are being used into multiple autonomous vehicles. Then smart grid, which is a future where we need to handle the energy distribution, how energy which gets generated through maybe renewable energies as well as utility. Then industrial control system where it would be a part of the PLCs, HMIs, the smart robots which operates into an industry. All in all, CPS are now part of, if you look around, they are part of our day-to-day operation, day-to-day life, right? Now why do we see the sudden rise into CPS? Now CPS are not something extraordinarily new, it's like an era where we see a need of those CPS system. So I was going through an article, and what I surprised to see was these are the top 10 industries where we see a significant impact into the cyber physical system. And the highest impact is onto the cyber security for obvious reasons like the risk or the threat modeling or the systems getting hacked, which is crucial, right? And need not necessarily that every time your system needs to be connected on the internet to get hacked. It can be get hacked by just transferring small file. Just imagine a situation where there is a plant which is being controlled by your PLCs or distributed control systems, and somebody knowingly or unknowingly able to get access to that system. You can completely destroy the financial dynamics of the plant and can even lead to a hazards to life and the infrastructure. Similar way, there are other areas which we have already discussed, like healthcare, automotive. There is a significant impact on CPS. And why this primarily getting increased is because of imbalance into the demand and the supply. So which ultimately, if we see the social, economical and the availability of the supply versus the demand, which actually driving for a more and more CPS system to make an ace of making our life easy, getting data more accessible. Then easy availability of internet, which also leads to a tremendous rise into the CPS system. So there are many IoT systems which you could see in last maybe a 3 to 4 years than what it used to be a couple of years or a decade ago. And then advancement in technology. So we now have more computation power. When I was studying in the college, 8051, I think some of your professor may be able to recall, the 8085, that was the best processor and controller which we can use to afford while working on our projects, right? Nowadays, you all are talking about Arduino, maybe even advanced the processor. So computation power is increasing and cost is decreasing. Every 18 months, we know like power gets processing power or the speed gets double, whereas cost gets half of it. And that's ultimately leading to a more increase into CPS. The more data can be processed locally, some of the insight can be thrown onto the cloud, but that's one of the critical elements. The key element here is the CPS are expected to grow at the rate of 10.5x. When we usually see the industry, the growth of 8% CAGR is considered to be for some of the systems which are need of an everyday uses. This 11% or 10.55% growth only for CPS is ultimately going to be the part of next connected systems or smart cities, and that's where it is important to consider an important area for you to focus and do the research or work on it. How CPS are different than traditional systems. So now we have known about CPS. You must have studied the systems as part of your curriculum. The CPS can be considered as a systems of systems. So the way you look at the diagram, there is a close integration, the connection between cyber and physical. So that is the one element which is related to embedded processing or what we can say that the electronics of the embedded system. That device basically interact with the system. So CPS can be an individual device, or it can be part of a bigger system, or it can be part of system of system. So think about an autonomous car where maybe a one system can dedicatedly look into avoiding the collision or accident, whereas one system can look into running the car itself without having a driver, whereas other system can look into communicating status back to maybe a server. So these all systems could be CPS. It can be a device, it can be a system, or it can be the system of system to take care of the final outcome which has to be delivered. Now, what are the critical characteristics of CPS? So I think the first point I already covered, which is system of system. Then data driven. So CPS should collect the data which from the sensors or the surroundings, and it should also able to connect with an IoT devices or drive the output or the actuators. Composable, meaning that the components of CPS can be reusable. So the way it's being marked into the diagram on the left hand side, a CPS device in one system can be reused into some of the other CPS system, and that's an important aspect. So your software can change into during runtime. Your component of the system can be combined dynamically, right? So it's modular or the scalable, which is a characteristics here. Heterogeneity, which is another element where when you design some of the CPS system, you need to consider an array or the diversity of a sensor which can talk, or the dynamics which can come into the picture with the system will be posted into real time. Multi-purpose. So repurpose beyond the intended use. So like an was never being prepared as a compass or navigator, but now while driving the car or bike, use mobile to provide it as the navigation device or the showing the map. Cross-domain application. So interaction between manufacturing and production, maybe healthcare and IT system. So few years ago, we used to have devices which will help you to take care or measure the ECG as an example, or some of the other healthcare applications. Now those systems can be remotely controlled. The surgery can happen, the doctor can be sitting anywhere across the world, and he or she can control the device, and the surgery can happen just next to us, and that's all application of CPS or cyber physical safety. And the security, so which is something inherent. When we talk about what cyber, I think that the element of security, which is or the safety, which is inherent. There could be a privacy breach. There could be a lack of data, personal data. There could be some data which can be interpreted and which can interpret the schedule or the thinking of a person. We must have heard in last US presidential elections, right? How the opinion, I don't know if the news were true or false, but the social media was being used to really change the opinion of people, and that's what actually, whenever we talk about cyber aspect or the cyber security or the safety, it comes into a critical element as a safety as an integral part of it. So the primary message which I wanted to leave here is CPS should be designed thoughtfully. We need to consider the end application, potential multi-purpose use of a system. Now, how the architecture of a CPS will look like. So there is a concept called TIC, which is like the connection, then conversation, cyber, combination, and the configuration. So connection is something you can map it with our OSI model, with obviously some changes in terms of the primary layer goes as the physical layer where the system should be able to plug and play. Like take an example about the mouse or some of the advanced devices where simply we connect it to the system and they would get configured, and you need to think about it as a sensor array or the getting the input from the multiple parameter. It could be pressure sensor or the moisture sensor. Whatever information we get from the sensor as an electrical signal has no use unless until we interpret it into some logical information, and that's the second layer, and that's where it's a multi-dimensional data processing, converting that data into some prediction, creating some meaning out of it. Then cyber, I think which I had covered, but there is one element which is important to look here is now we are going towards a digital twin. So the entire building or the complete smart city that can be converted as a digital twin, and then you can run some of the simulation to analyze how an actual scenario would be in real life, and that's where another dimension of the cyber comes into the picture. Omniscient is more like an integrated simulation, making some meaning automatically, drawing out of it, making some sense of the information which is coming through the layers, maybe from the sensor, cyber, and the connection layers. And finally, it's configuration. So, are these systems resilient enough if there are changes? Are those intelligent enough to make required changes into themselves? So, we just heard about the robot, autonomous robot for firefighting, right? So, is robot mature enough or smart enough to sense that if a fire which that robot is going to get entered into for saving the lives of others, what type of fire sources it was? Is that robot mature enough to take an appropriate actions or without getting or waiting command from somebody else? So that kind of self-configuration for the resilience, variations, and the disturbance. I think that something is important by developing the CPS system. Now, what is moving even next few steps ahead. So, I talked about the 5C model, which is pretty common and being in use, whereas industry is going towards the 8C. Now, what are those three dimensions which are getting added? Which are cohesion, customer, and content. So, it's predominantly considering the customer aspect, involving customer during development of a system, so that a perspective can be considered how end user is going to use a system. An important aspect. Then content is about extracting, storing, and inquiring the product traceability report. So this is one of the example, like how we can trace and have the record, which ultimately in future, given context while taking up a decision, the system should have that context already been known. And then the integration, which is like here we have seen on 5C model, it's all integration. Here we are talking about the value chain integration with the manufacturing, more about an horizontal integration, getting information from one process and connecting it with another process or from one system to another system. So design challenges and the consideration. So design consideration is quite critical and important for the CPS. So we'll start with the sensors and actuator. So that is something as an electronics engineer you all are already aware. It's an interface with the physical world. You need to see if sensors are self-charged or it needs an excitation from the system. Then the programming is a critical aspect, but we wanted to move away from the programmability to autonomous and self-cognition of the system. As somewhere, rather than everything getting programmed, is system capable enough to have the autonomy of or the integration of a programming with the cognition of what system is expected to deliver. The digital twin, I think that's I had already covered when it's a representation of a physical system and ensuring that we can run the simulations, we can run the more detailed level analysis before we take it to an actual world and try it out to the physical devices. Positioning and mapping. So mapping is something which provides a structural view. Positioning is about like GPS coordinate, the locations. Where the mapping is something which provides about the structural view. So imagine some of the high-rise buildings, and there you need to think about a firefighting system and how this CPS will get, or any kind of the cyber physical system, maybe a robo what we discuss, or more advanced system which will get implemented there. And then the security. So security predominantly talk about the safety and cyber security. So security, when we looked into the safety, the primary as a designer, the primary aspect which needs to be considered is your system should not take the action which is non-intended, and more than that, it should not harsh or tarnish, right? Either the infrastructure or the should not the life. Whereas cyber security is more about remotely somebody attacking, putting in the virus or the malicious attack on your system. There is one more aspect which is not being mentioned here, is about hardware cybersecurity. So when we think about cybersecurity, we always think about a firmware or software which needs to be secure. But hardware cybersecurity is actually gaining a lot of momentum over last few years, where while I was working in Eton, and there were being guidelines given like you cannot choose a certain type of controller because they are not immune or they are more prone to a hardware cybersecurity attacks. So that kind of the provisioning organization are doing, they are going to a level where a microcontroller or microprocessor would be only developed and dedicated for their application and only used by them. So that would be another dimension as an electronics engineer we can always look into it. And hardware is going to be a significant area going forward as well. So it is crucial to design the reliable system ensuring the integrity of information. I wanted to highlight or stress more onto the integrity of information because any device, be it a smart device, IoT device, or maybe a cyber physical systems or other devices, the information or the meaning they draw out of that signal processing should be reliable and accurate enough so that as a human we can trust on them. We can use that data and it can ultimately help us to fast track our development process or fast track our decision making process. So that's all I have to cover. Maybe we can take 2 minutes if you have any question, any thoughts, any comments from anyone of you.
Is there any questions? Okay, since that there are no questions on this topic, I suppose. Okay, so I invite Manoj sir to join Rishikesh Kupre sir to present the paper on cost and resource optimized HMI for industrial automation.
Thank you. I'll take the initial couple of slides and then I'll hand over to Manoj. So I will discuss about CPS and one of the reasons to take CPS as a topic because we operate in the domain of PLC, HMI and some of the other smart products, and that's something even we wanted to get deeper into our organization. So though I covered about CPS, we don't claim that we know everything today because it's still a field which is evolving, we are studying about it. And it's one of the aspects which needs an attention, and that was the primary purpose to consider. Now for HMI, when we are going to talk about when preparing this white paper, our focus was on to the few HMI as a system, why it is important and how does the market look like. But more than that, there are a variety of HMIs available in market, and here we are going to talk more about the products and the technology which enable us to bring this product. The HMIs are available in different sizes, variety, it goes into different applications, or different technologies where you can develop the HMI from bare metal, you can develop it onto the RTOS or the Linux. But ultimately, the hypothesis here is you keep on increasing the more computation power of your needs, which ultimately leads to a more cost, more resource. And that's something we wanted to break as an organization. We took up a challenge that we wanted to develop a HMI which can be affordable by a small customer, which would be cost and resource optimized. My colleague Manoj would talk a lot more as he is core designer and architect for that. But I'll cover with an initial few topics and then we'll go into the core topic for today. So this is what we wanted to cover as an agenda. Introduction, I think HMI as a word, human machine interface, doesn't need much introduction, right? So HMIs are there into our smart wearables, those are into our mobiles, automotives, we see onto the displays of like Ola, electric bike and many other cars. Here we wanted to talk about HMI more from an industrial application. The HMI which goes onto the panels, HMI where you can give the commands, maybe something which goes into healthcare, right? If you have seen some ECG machine, if you have seen some of the other applications into healthcare, there it needs and touch or non-touch HMI to give the command. Again, nowadays HMI means only a touch-based HMI, need not necessary. It would be just taken as simple example, having maybe a refrigerator at home and we have option to control the cooling, high, medium, low, right? That's also HMI. Anything which allow human to talk to your machine is an HMI. And you could see a different variety of HMIs and those are used into a wide range across the industry. Application needs. So HMIs are predominantly used to control, monitor the processes, store the data logs, make some meaning out of it, and take the decisions, right? Now, as world is evolving, what we are really looking forward is everything should happen at just a simple click. And that's what we came up or called it as a recipe. So, you create a list of steps during configuration, you store it as an application in HMI, and just with click of a single button, the HMI processor will take care of those actions will get executed. What are the different application areas and domains? So HMIs are used in automotive, medical, industrial, healthcare, and many more applications, multiple commercial applications. But when it comes to industrial, predominantly it's being used into multiple pharmacy, medicals, oil and gas industry, right? Where you use different enclosures, which would basically to control panel and HMI can be used to control them. Transport application, new electrical vehicles launched by our PCMC, right? Where you could see an HMI based control. So on and so forth, it's being used across a wide variety. We can see HMIs across all of us, but still it takes a unique proposition when we look into the kind of growth of the market available. Now what we wanted to highlight onto the image which we have articulated there, though HMI is a device which is used for control and monitoring process, it cannot do it by itself. I mean, there is a category of HMI where you can have some of the IOs integrated or the PLC integrated into it. But having said that, it will still need you to integrate with the sensor, relays, actuator. It can communicate with drivers, it can communicate with your data logger devices and a nearby proxy sensor. And which basically ultimately makes that HMI system more complex to design. You need to be thorough while choosing an HMI for your systems, and designers need to be a lot more cognizant while making the development of a HMI based on what end application are being targeted and how generic HMI you develop as part of your development. And that's where we enter into the key ingredients of HMIs. So we usually think HMI as more like a hardware, but believe me, hardware is critical and important, but hard lies for HMI into the communication and of the embedded firmware which sits onto it. So hardware offers that processing power or storage, but it's a software which ensures that the generic or the multiple use cases which will be covered, and the communication brings on the exchange of information between hardware and software, and not only that, but to an external to a system. Now, how does the HMI market looks like? So HMIs are not new, right? Almost since maybe 1980, the initial HMIs with keypad and LED started, then there has been a significant growth. But we just recently onto a data, how does a market stand even today? So if you look into 2023, which is 5.2 billion market, which is quite big, and it's expected to grow at a rate of 8.2 CAGR, which would be reaching to 7.2 billion into 2020. Now the reason why I wanted to discuss about it, still there are significant opportunities for electronics engineer to do a lot of new innovation into HMI. Our future is even, we have not tested fully as an industry or as a community of engineer. So there would be there is a research and development going on where you can have a brain controlled HMI, right? So there would be sensor put onto your brain. You think about something and then that actually command goes to a machine and then machine interact. And believe me, when I am picking this example, they will not see the HMI per se the way we are seeing it today, right? There would be something, some sensor implanted or maybe put onto our head. You think that I need to turn on the fan and it will get turned on, right? It looks simple, it's possible even today, it's not cost affordable. And why I'm calling it as a HMI because you are, as a human, you are interacting with machine. Today also that can be possible through remote, but you still need to press few keys. And here we are talking about something where your brain electrical signals will make that happen, right? So that's the reason I wanted to highlight. So this element, like 7.2 billion, still doesn't include such innovations which are expected, which are going to happen, right? Currently also there are HMIs which are voice control. You just need interaction required, physical interaction required, and it will operate onto that. Now, when we look into the APAC, there is a significant potential growth which is happening. Be it within Asia, it could be China or it could be India. We are growing, and there is a higher and higher demand for this smart solution or cyber physical system, and one of them could be an HMI. And why this is happening? So one of the predominant reason is Industry 4.0, where most of manufacturing industries they wanted to get into a zone where they will have more improved productivity. They wanted to drive efficiency. Not only HMI, there could be many other solutions, but HMI would be one of the solutions which is helping them to achieve this. And then efficient control and monitoring of the processes across the industries. Right? Now, what are the market dynamics? So now we know that there is a bigger market. As an electronics engineer, we all have an opportunity to contribute into it. Now, what market expect? What are the market demands? So, guiding operator is the risk of the error. So, which basically through HMI you will get a better safety. If some machines is not working or there is a problem, HMI can highlight about it. Then visibility and performance of machines. That again, I covered that point. It will provide the enhanced productivity. Ultimately, you produce the more products on a same setup. Your investment remains same or reduces, right? Then graphical representation and interpretation of critical data. This is very important, right? If something is get populated as a table versus graph, as a human eyes and brain, we can quickly read with a graphical representation that drive to faster decision. If you need to increase the speed higher or reduce it, if there is a right amount of machine and something is being highlighted, rather than words, the image or the graphical interpretation gives them more strong connections to human. And then identification resolution in case of failure. So providing more like the timely and the preventive maintenance. So HMS are going to be important part of our life in the industry, across the industries. There are going to be a lot of innovation which is going to happen. Now I'll hand over to my colleague Manoj, who would basically cover about or talk about how we as an organization or how we as an architect of our system leverage the bare metal where a safe performance or optimal performance being delivered in cost and resource optimization.
Go to the further slides for the HMI. So till now, we have checked about HMI and market demands. So the last slide, so product requirements, the functional requirements, and what the HMIs. So here. Areas, as we have seen in the earlier slide, for each application segment. So as per the domain and as per the requirement, HMIs can be classified based on the different categories. there is application based on the technology. HMIs basically interact human with the machine. So how human interacts based on that also HMIs can be categorized as certain or even a fan regulator or a fridge. That is the HMI. So again, can be categorized into the HMI. So nowadays we are already on the path to come in the industry, and we are set ready for the gesture based in computing based HMI also. So that is the future ahead. These technologies are evolving not only in HMI but also in other different electronic products. So based on these technologies are evolving in the medical applications, automotive sections, as well as the industrial domain. In the industrial domain, mainly the process grids to control the processing and different machineries, the HMIs are used. So depending on that, you can say pharmaceutical, current gas industry. Some HMIs may be used to control the process, and in the same industry, there may be are required to be set on some panel. So depending on that, the HMI can be classified into different applications. In different sizes also, we can classify HMIs as per the different main concern, because all these categorization it brings to the different requirements from the HMI. Like if we compare the 4.3 inch HMI with the 10.3, so someone may say that 4.3 inch HMI is quite simple. It might be quite simple, but as per the application requirement, from the 4.3 inch HMI and the 10 inch HMI might be same. So the challenge here, the main challenge, all those features in the 4.3 inch HMI might be more challenging than the 10. But it does not mean there will be no challenge with the 10.1. Only for example, you can compare any type with. I want to just highlight that at each category and each section, so depending on each HMI, there will be different challenges, and all challenges actually, if we contribute it to the requirement, then everyone wants continuously increasing high performance and plus user experience. So the hassle-free interaction for the user with the increased performance. So all it is required with the enhanced feature, which is growing as per the technology. So all this has to be covered in the HMI. So for that, we will be requiring the high performance HMIs or the high performance technologies, which will means most of the time designers, they will draw a conclusion, or they will believe that these high performing devices, it will be only possible with the highly efficient platforms. Will be based on the high-speed hardware, and which will actually increase the cost of that device. The same is the case with HMI. So, but when the cost increases, as we have covered in, if there is a 4.3 inch HMI, which is the, so if we go with the high performance and high efficient product, and if we want to cover all the enhanced features in that, the required high performing hardware and the high speed hardware, whatever will be the cost of that HMI, that may not be. If we collectively check the size of that market, we may lose a quantitative market session for the HMS because their feature requirements. If we go on adding the features on the performing devices, the cost will eventually increase. But the particular application section, that segment, that HMI in that bracket. So reduce the cost for all enhanced features with the high speed performance. We have to reset this again, that how we can give a cost optimized design for the highly efficient and the resource. How we have come across this? Mostly, the breakthrough is most of the time the designers are rushing. Graphical frameworks and the increased performance based on collecting the extremely flexible implementations. So everyone is trying to achieve the best in class, best interactive set, interactive logic and real-time responses. So, but when any designer we require the high technology and high performing platforms. So it is believed that to and the real-time experience, we should require the high-speed platforms. The high-speed platforms mainly work on the high-speed hardware or the microcontrollers, which are costly, and it will also require the bulky operating systems or the libraries or the stacks. So all these increases the burden of the code and eventually the processing of the devices, and also increases cost of the device. So if we calculate all these things, then again in the previous slide, as I explained, it will be a bulky affair, and it will not be affordable particular market segment. So to bring down this cost and the bulkiness, we have resetted the billing and started from scratch and just compare certain theories. Why this solution is bulky and costly. So the reason behind the solution is bulky because the heavily loaded block, many times the operating system or the libraries or the stack controller, even a high-speed performing in performance, and for that we will require even the high-speed, high-performing hardware. It increases the cost of that device. So if we nail down these two things, So we can bring down the cost and we can target that particular market segment which normally is very cost sensitive even for the HMI devices. Factors affecting which may bring down this load are mostly based on the platform, the software platform which we are using on the hardware or the microcontroller. So if we compare the bare metal code and normally anyone is aware of what is bare metal. Bare metal is if we write from scratch and it does not OS or kernel and we are not directly deploying our applications on it. Okay, so we have to write the drivers, even we have to schedule each and every task by our own, and such code is called the bare metal code. So if we compare such code, all of you must be knowing, but if we compare as per our requirement, for each and every application, we must go ahead with the bare metal design or the OSS design. Then this is some comparative analysis. So mainly the key points we have analyzed that the technical strength required to develop any application or to develop any program on the bare metal is really basic technical strength is required. So we did not to invest on the developers or the designers. Also the development time, that is at initial stage, but it will reduce further once we have developed our models. So if we can architect, if we can systematically design a modular approach for the program, so we can achieve this. There is no extra cost required for the bare metal, but whereas there will be cost for the maybe Linux and WinC. Procure the OS at certain particular price, so that cost also we can reduce. So ultimately, this will how we can achieve this. So the carry through for the fulfillment will be what all we need if we want to go with the bare metal code. That we should identify the devices as we have covered in the earlier slides. Then sort the required resources for each and every requirement, whatever features or whatever the application, particular application. As we have covered in our earlier slide, which interfaces are there, what are the ingredients for the particular application. Those we have to identify and we have to sort accordingly. Resource with the optimum usage, prioritize them, and this collaborating all these things, we can develop a highly efficient and best-in-class HMI device. Conclusion: we give all these enhanced features running way to target all these 6-7 parameters. So develop a highly efficient and effective architecture which can bring the best-in-class HMI.
How it will be platform flexible?
Platform flexible means because we have developed the drivers, application modules. normally, if I compare with the Linux or any other operating system, they are also, when they claim that they are platform flexible. Platform is hardware flexible. So when I want to move from one controller to other controller, actually they support that particular OS has to support that controller. Means there is one HL layer which they have already written for that micro. That part they transport and deploy from one platform to other platform. So if we have the platform flexible is the requirement. So we have to develop our architecture as per it can be the platform flexible. So what we have to do while designing our architecture, whatever hardware related things, we have to sort it out and we have to write the different functions for it. This modular with the layer, that HL layer is different. Means the drivers are written separately and the application area is written separately and the compatibility is means if we can set some standards, like if I have to transfer some buffer, if we are using some say CAN interface or the UART interface. So all we require, we have to only enable the module and we have to transfer one buffer and its pointer, maybe the size. So these 3-4 points are required. So if I write a middle layer according to this requirement, so it can pass to any hardware. Only I have to change the driver for that. So when if a complete HMI or complete product program is written and now I want to ship the platform, okay, I need to write only the driver. So a complete application in the middle layer, that will be platform independent. But definitely we have to, if it is bare metal, then we have to write the driver. If they provide the compatibility feature, then they provide the write our own HM. It will not suffice the platform flexibility. It is that we have to we have to write the code so that it will be platform flexible application. And it will be more efficient than the OS based code, because what happens many times the middle layer, it is according to number of it can be flexible across number of platforms. So when we write our code, we can execution so that it will be applicable. It will increases its efficiency. But if I write the same code for which will be compatible for 50, then that automatically its efficiency will be reduced.
Thank you, sir. Now moving towards our next paper presentation. Shinde, Atharva Munse and Pragya Rao, where the paper title is IoT based smart inverter. So I invite the Astik, Atharva and Pragya for the session.
Good afternoon, everyone. So, today I, Atharva, Astik, and Pradnya will give the presentation on IoT-based inverter. So, good afternoon, everyone, again. So, you must all have heard about the traditional inverters that we are using in our homes or industrial applications. Also, inverters are also used in EVs nowadays. So, what is an IoT-based inverter? So, Internet of Things must all be hearing. So, it has a very big application in the inverters. So we'll be starting in the presentation. So inverters are widely used in the industrial application as well. So the inverter that we have designed is the inverter that will be monitoring voltage, current and the temperature in the real time. So it will be very much useful because the battery life will be monitored, and so it becomes more sustainable, and we can have the data of all the battery voltage and all can all be monitored, and we can get the data, and we can also do the analysis using the IoT.
Objectives of our project. Firstly, we will check the inverter output, which will be compatible with the common electrical appliances. After that, we will show the required parameters on LCD, which will be interface with microcontroller. And after that, the displayed data will be stored and shared to the cloud. And we will make a mobile application through which a user can retrieve and analyze data from anywhere.
So why IoT inverters? So these are features for IoT in inverters. For monitoring and control. Second is insights and analytics. Predictive integration with grid interaction and stability. So, in this prototype that we are building, our primary focus is on recording and control. This is the workflow that I'm going to explain now. Firstly, we have a 12-volt DC battery here. The block diagram. The left side part is the traditional inverter part, and this is the IoT part that we are interfacing. So first, the from DC to AC, and which for monitoring the purposes and which will take analog inputs from the sensors like current and temperature, and this will be LCD, and via application, which is also provided by the link server. We are going to view the data on the mobile. So, looking at the previous block diagram, we can. So, why we are using two microcontrollers? This is a dedicated, provides a dedicated functionality, modular design, resource optimization, reduced architectural complexity, and reliability. So, for dedicated each microcontroller is having its own purpose, function. Uh, it's used for taking the components of inverter, transformer, resistors. ICs like you can see IRF3250. This is a MOSFET based in here it's also an IC called CD4047. It's a multi-vibrator monostable oscillator IC. For switching it on and off in complementary fashion. Of IoT like big LCD for the analog taking the inputs from analog input and convert it via ADC communication via from A to D conversion. LCD, as you know, LCD takes on ASCII parameters for that. So we are giving the ASCII value for displaying it on the LCD. This is the hardware setup of our. Here we are displaying both the parameters in digital as well as, but while sending to the IoT platform, we are only giving the only again reconverting with an equation. Why we are doing this? As it can interpret and we can add an alert system, sending add a threshold to a certain value, which can interpret. These are the applications which will be further extended.
So IoT inverter has a lot of applications, commercial and industrial facilities, smart home integration, resident usage, and especially the EVs part. As you must be hearing about, sometimes the EVs are catching fire. It's there in the news sometimes. So along with the BMS, if we put this along with the BMS, then of the battery suddenly rises, then you can get an alert on the phone and then you will get to know that yes, it may be catching fire, and so this will work over here, and it will be also energy management and optimization. It will efficiently work as an energy management and optimization.
Conclusion of our project. Here we have successfully integrated ESP8266 with PIC microcontroller. Also, we have integrated IoT technology with traditional embedded systems.
Parameters you are sending on cloud and what you are monitoring?
Battery voltage.
Voltage, current as well as the temperature.
But if voltage is low, nothing was connected to the battery, so that action will be taken. Telling if battery voltage is low, you will get an indication, but only indication or some action to be taken. Nothing is connected to the battery to charge it.
Just now we are only giving an indication to the.
If it is
Yes,
low battery,
we can add a
charging
functionality.
should start. So nothing is connected to the battery.
Yes.
That's the only parameter you are monitoring.
Yes. Currently now.
Output is 5 volts.
No. Yes, for 5 volts. Complete output is 5 volts.
At which terminal you are getting that 5 volts? Which terminal over here?
Sending it serially to the load you also. The battery is 12 volt, but we are adding
Battery voltage only 5 volt. That was.
It works on 5 volts. Battery voltage.
Use 5 volts digital output. So what is that 5 volt output? Where you are getting?
5 volts we are converting it. The controller, it works on 5 volts. So we are adding a battery
Now,
voltage.
what load?
Bulb.
Huh?
Bulb.
Bulb.
Now we are just adding a voltage divider, voltage sensor to it, which 5 volts, so we can show.
So what is the purpose of this inverter? What loads you want to run on that inverter?
Batteries usually get damaged because of sometimes the low voltage gets lower.
If everything is about battery, what is?
Really, they have just added the IoT part to the inverter.
You can.
Title is IoT controlled inverter, right? So how microcontroller it controls the component in the inverter. In the inverter, right? So how your microcontroller it controls operation of MOSFET. In inverter, MOSFETs are used, right? And microcontroller, your title is IoT controlled inverter, right? So through mobile, you are controlling operation of inverter.
We are monitoring this. So the control parameter.
IoT based smart inverter, not IoT based. Correct? No? Am I correct? Can I ask?
Yes.
How do you generate sine? Here, how have you generated sine? What have you generated?
Square wave to the figures.
That is not correct.
Yes, sir. But it can generate. We are not gone into that yet, but we can.
Actually, you are at least attending something core. See, you should be considering on day one, how will I generate sine wave? At your home, you use inverters, correct? Are they sine wave or square wave? Then the circuits are also available. Correct. Sine wave, what will you monitor? In sine wave, what will you monitor? We will monitor IoT because that is what needs to be monitored, not the battery. total harmonic distortion, RMS value, because that will burn the fan. Why will it burn? Because
Square wave is a combination of sine wave combination, square wave, multiple sine waves.
very good. So, it doesn't matter if you say I don't know, that's fine. Because earlier you should say I don't know these values. And these are called RMS. So higher frequencies will burn the winding, will not act as a potential electric vehicle also. So this is what inverter is the art of it, not IoT. You want to change your focus to inverter. Because unless your inverter is distortion, RMS value, and square wave can be generated to sine wave. They have what is known as class D modulation. Class D modulation. You are finally here, correct? Yes, we are already here. Come to me on day one. Class D modulation. Where the PWM varies as per sine wave. And if you take the low pass filter integrate, you can see. But it will not be still pure sine wave, but you have to aim at minimum total. Goes on discharging. You will switch off. There has to be charging circuit if it is used as a backup. Charging circuit from 230 volt. Otherwise, you will switch. Charge the battery or give alarm. What is the square wave frequency? You have 50 hertz. Okay. How did you select the MOSFET? MOSFET selection. Inverter does not have macrocontroller. Yes. It has a doesn't have. Really, you need AC to run that inverter. It's not controlled. Because inverter can be random. MOSFET selection also matters because that is what you have to learn. How to select a component, how to read a data sheet. Even now you can, that is what interviewer is going to ask. How do you ensure MOSFET temperature? Can you give? Okay, thank you, madam.
Now I invite Christy, Neeraj, to present their paper Low and high-speed generic reversible BCD adder on FPG. One of the authors is Dr. Kanchal Tiwari also.
Good afternoon everyone, I am Simrit and my teammates Neeraj and Christina and we are going to present this project for you today. So as we all know, throughout history we human beings have always been consumers of natural resources and not replenishers of natural resources. And also with advancements in medical fields and technological fields today, we still continue to be consumers of natural resources. And with UN declaring a global climate emergency 2023, sustainability is now the need of the hour more than ever. Keeping that in mind, we have chosen a sustainability related project, and also as ENTC engineers, data that not many people touch, just researchers, because it's very complex, and also certain drawbacks of VLSI domain related is that there's power dissipation, that's a problem, certain environmental concerns, and also security concerns. So that is what we're going to tackle using this project. So that's why combining sustainability and VLSI as a domain, we have chosen this project titled Design of Low Power and High Speed Generic Reversible BCD Adder using an FPGA board. So the co-founder of Intel, Gordon Moore, basically predicted that every 18 months, the number of transistors on a semiconductor chip double. So every 18 months or approximately 2 years. Now recently, NVIDIA have removed a chip on which it had 189 billion transistors. So the Gordon's Moore or the law of Moore or his prediction is still pretty valid. The only difference is now it's very faster. So instead of taking 18 months, it's taking 2 months to achieve that transistors on a single chip. Said that every decimation of KTLM to the base 2 for every bit rate, that's the decimation that happens when we use conventional gates. Now to circumvent that or to prevent that, Bennett predicted that we are going to use reversible gates. So what are reversible logic gates? We are going to see that. This is the Moore's graph, which actually proves that every year the number of transistors also increase. So what is reversible logic? So when we take reversible gates into consideration, the basic inputs and the number of outputs have to be equal. So basically there's a one-to-one mapping with the input and output. So what is this? This is what we call logical reversibility. So from the inputs I can get my outputs, and from my outputs I can get my inputs back also. So the operations are bijective. When we use conventional gates, this is not the case. Like we use AND or OR gates, there are only 2 inputs and 1 output. So there is a loss of information or heat dissipation that comes here. So when we have equal number of inputs and equal number of outputs, the power dissipation is reduced here. So that factor where we are reducing, where the dissipation is happening, that is reduced because of reversible gates. And one thing, the rule that reversibility has to follow is that the number of inputs and outputs have to be equal as shown here, as well as the number of constant inputs and garbage outputs have to be very constant. So why we are using basically BCD adders? So adders are the heart of every processor, and the thing is that all researchers have only worked with 4 bits, 8 bits or max to max 16 bits in their research projects. But our novelty is that we are working or we are scaling it up to 16, 34 and 32 and 64 bits. So that's our novelty using the Coxstone adder that will be introduced further as we've actually algorithms for this project. And also what's happening is when the number of bits increase, like as I said 32, 64 that we're working with, the complexity increases. So the time period also increases, power dissipation is also increasing. So that is what we are trying to combat through our project using some novelty. So our objectives are that we are proposing for of it, and they are studying that using an FPGA board. We are going to see the output using an FPGA board. The 5 main research papers that we have actually referred, we referred more than 30 papers for making our papers and submitted in various conferences, but these were the highest citation ones, which is displayed here. Over to you, Neeraj.
Hello. Thank you, Christy. As my colleague Simran explained about the reversible logic. So now let's understand what are the So as we can see, I have mentioned over like 6 reversible gates. One of them are like HNG gate, SCM, CNOT, Toffoli, NEW gate, and Paris gate. These are the highly used gates in the industry. The SCM gate, which we see over here, it's a 4x logic in a BCD adder. Another gate ladder in BCD algorithms. So this is the general block diagram of BCD adder. What is a BCD adder and what's collection logic all about? As we A and B, which are 4 bits, and one output Cin. Cin is a forward carry that is generated from the previous block. Two outputs, that is sum and one carry. If the logic of BCD adder is like, if the value of addition is greater than 9, then we will get a carry. Carry equals to 1. And carry is propagated to the corrector logic. The work of the corrector logic is to add a binary 6, that is 0, and provide that is at a second input to the parallel ladder 2. The input from the first parallel ladder, second is the corrector logic. The final output comes to be the sum and the C out. So this is the first algorithm that we have implemented. As you can see, there are 8 THG gates and 3 NG gates. The first 4-bit parallel ladder and the bottom 4 THG gates acting as a 4-bit parallel ladder. Here the NG gates, 3 NG gates are acting as a corrector. This is the second algorithm. Over here, we can see the parallel ladder, which is made up of HNG gate, another HNG gate. Here the NG as a corrector logic over here. This is the third algorithm. The third algorithm also consists of HNG gates, SCL gate, pairs, H. Here the SCL gate is acting as a corrector logic. This is the Coxstone adder. This is the latest technology. This is the latest technology that is available in BCD addition technology. As you can see, the Coxstone adder is implemented using the conventional gates, like AND gate and XOR gate. The Coxstone adder is the fastest adder as of now available. So, I'll move forward with the methodology. Methodology, we are at the VHDL entry. VHDL entry is nothing but converting a diagram into a program. Verilog code or VHDL language. Check for any kind of errors available or not. Simulation. In simulation, we check the output on a test using a test bench and compare the result with the output. Next, from the timing analysis, finally the testing. I'd like to hand over to Christian.
Thank you, Neeraj. So basically, you might be thinking why we are using BCD logic compared to binary. So basically, in binary, when you do a normal addition of 0.666, you have to first make it into 2 raised to minus 1, 2 raised to 0, 2 raised to 1, 2 raised to 2. And comparatively, when you see the addition of that, it comes around 0.625, which is not correct in terms of logic. Because when you add two numbers of binary, in terms of binary, the addition comes to be approx value. But in BCD, when you do the addition of 0.666 with some other number, like for example 0.999, we take individual numbers like 0 is considered as 0000, 6 will be considered as 0110, likewise. So, talking about the results, these are the simulation results software, and here is the RT7 FPGA board on which we have run the simulation and tested the code. Basically, here it's a 16 input board. So in first 4 inputs we are storing 5. In second all 4 inputs we are storing 1. In third we are storing 4, and for last 4 we are storing 9. So basically 51 plus 49 comes around to be 100, which is shown on the 7-segment display. So these are the numbers of the part area. So as you have seen the algorithms, the conventional logic is taking a lot of seconds. So these values are in nanoseconds. So it is taking a lot of time compared to the Coxstone which we are currently working on. We are working on its novelty. So 0.9 compared to 2.2, it's a lot of difference. So the part delay is less. This is in the graphical format, the same results. Garbage values. So garbage values are the values which are not used in the final output. Quantum cost is the number of resources utilized by the whole gate and qubits, and its constant inputs remain the same. So these are the power utilization by the BCD adder. As you can see again 0.06 is the least amount of power dissipation in milliwatts. So at the end I would like to conclude our main focus is to reduce the power and get the lowest part delay as well as low precipitation in the BCD adder. These are the these are the references we have used, and that's it from our side. We are open for the questions. Thank you for your patience.
You have shown the comparison over there. So my question, different gates in first two slides. So while comparing also, same gates were used for the calculation. So in that gates also you shown.
And the algorithms are implemented using those possible gates.
So in all algorithms, you tried on same different gates.
This algorithm we have SCM. And the final output, like what we are getting, we have just compared all the output.
Comparison should be on a type of gate. When you have 4 algorithms, you should implement all the 4 algorithms for single gate. Comparative set.
So I will answer this question. Actually, ma'am, the algorithms which you are seeing are taken from proposed paper. So basically, we are testing. We are on a research-based purpose right now. So we have taken the paper concepts of the algorithm and then implemented the algorithm. So basically, we are on a proposed design, not an implemented design. You want to add something? These results are we have got on the Vivado software. When you simulate the code, we get the results in the tabular form. So basically, these are the results which we get when you simulate the code. I mean, it makes a difference. Like I talked about the quantum cost. Quantum cost is a number.
Ma'am, as you told, like you asked, like if we should get different algorithms. But ma'am, if we use the same, and research studies like using different kind of gates. How you use the power dissipation and the path delay. So ma'am,
This is the comparison algorithm.
yes, ma'am.
Your algorithm, correct?
So this
your algorithm being different. If I am correct, I will be wrong. Then gates will be different. That's what I am. I may be wrong. This philosophy, architecture. That is what I am. I may not be correct. No. Then her question is correct.
So what happens is that every gate has a certain quantum cost, the number of resources that it's using. So ma'am, every algorithm has different quantum cost. So when we combine all of this, when we calculate the total quantum cost, so we need a minimum quantum cost. The number of resources that it needs to be minimum, so that power dissipation is also less. The power dissipation also less. Heat generated is also less. So ma'am, all of those algorithms. So we need to find a way in which from how you compare.
and ma'am, to add on that, ma'am, each and every kinds of it. My main point is that these algorithms are already proposed by another researchers, and we have different weights like 4-bit, 8-bit, 16-bit, 32-bit. So, ma'am, like our main motto is like these all algorithms. See, like in algorithm one, if you implement our path delay is 2.57. 64-bit is like 30. If you compare it another algorithms for the same 64-bit.
So matter is you are
Coxstone error is also being seen in the papers, but it's in the conventional logic. What we are doing is we are using the conventional logic of Coxstone. We are putting a top level model of BCD converter, which converts the binary output into BCD and then adds the same. So when we do this logic, we get the least amount of part delay. So that is something people are not doing research in. So that's why, and if you see the research papers as well in IEEE format, Coxstone error is something people are not working on. So we are trying to work on that so that we get some kind of novelty in that.
Operations. Compare the number of operations required. But I'll propose to put them at existing one.
So you are talking about the conventional Coxstone and the reversible Coxstone, right?
Whatever algorithm you are proposing and the previous algorithms, number of computations.
So the conventional Coxstone adder is just a normal conventional adder.
But there is a mathematical log to the base, base to 2 raised to n like that. So have you compared such kind of things or compared? Number of bits, I think, depending on number of bits.
So for Coxstone adder, we are still in research work, and we are
because
studying.
without that we cannot. Although forward dissipation is less and all.
Sir, we are not telling that it's the best, but comparing all the results, as I said before as well, we are at the research stage. Comparing all the results are in front of your slides. So comparing all the results, we can see that Coxstone is the least, so that's why we are looking. At the end of the day, adder is
because you are using reversible logic.
Yes.
So it might be possible that even though dissipation is less, but number of operations will be increased in this case. One-to-one mapping.
Yes, sir. Operation might increase.
If you take and it is two inputs, one output. So mapping wise, output is less compared with input. So number of operations will be reduced.
Yes.
That is one more parameter for yes, that is one of the parameters that you can use. Yes. Computational complexity you have to find it out.
Yes, sir. We will do that. Actually, we are still working on Coxstone, so we try to add this point in the further studies.
Because any algorithm you want to compare, but computational efficiency has to be carried out.
Definitely, sir. We will try to find out that. Yeah. True. Thank you, sir.
Do you think that reverse gate reduces the power? What is the philosophy, root cause principle, fundamental behind it? Just because it is reversible.
Reversible logic, we have to one-on-one mapping means like we can predict the input from the outputs. That is what we point. And like in that one-on-one mapping, main issue that we face adders is that the power loss.
What is the fundamental principle? Power is voltage into current, right? So why? What is that magic? Just because it is reversible, I can find that there are more pins actually. Why should it reduce power? Why B into I less in reversible?
So basically, so we don't have gate and conventional gate and reversible gate comparison. So sir, what happens is, if we take a normal AND gate, so 2 inputs, 1 output.
Okay.
So sir, let's say we have 0 into 0, 0 and 1 into 0, 0. So sir, for 3 of those inputs, we are getting 0, 0, 0. So when we talk about the reversible gate, so let's say a C0 or a Fenton gate. So let's say C0 gate, so there are 2 inputs and 2 outputs. So what's happening for 0, 0, we're getting 0, 0. For 0, 1, 0, getting 1, 1. So the predictability, where there we had 0, 0, 0. So to predict from which of the inputs did I get 0?
No, power. Power. When I power, you should focus what is power. power is being divided, correct? You take a gate, calculate this being, find power. Go into internal circuit. What is it different in reversible power gets used? That is. And you cannot say the research says like that, research says it is not. A decision has. Then I say, yeah, I have taken this design. Then the three alternate to three. These root cause, circuit root cause, that's what you have to say. Not that I will have all five and then I will see this is over there, then I will research and all these are your design decisions, correct? So these design decisions have to be taken care as a professional, then engineer.
Yes.
Not architecture. It means algorithm, means not a software algorithm, but different circuits. So circuits being different, it is gets a.
Yes.
Correct.
Thank you.
Thank you, Christy. Now we will have a coffee break of 15 minutes, 10 minutes.
Just 5 minutes. I know you all are waiting for Best Paper Award. Just give us 5 minutes. Within 5 minutes, we will declare it. Till then, please fill feedback form. QR code is shared on the screen. Those who are not going to fill feedback form, they will not be coming among the winners. It's also.
बोल ना ऑर्डरला आहे. सात वाजता. किती हजार रुपये? काम असतं ते भेटतं रे. काढायला फक्त काय करणार एवढं? नाही टमाटर चाकण त्यामुळे त्याला तुम्ही देत नाही. आपलं पण मला वाटतं बोलू नाही.
काहीतरी आता पुढचं जे फायनल मॅमचं वगैरे ते सगळं झाल्यावरच बंद करायचं. ॲक्च्युली कसं बघायला गेलं तर त्यांचं नेट बंद झालेलं आहे, त्यामुळे आपलं लाईव्ह स्ट्रीमिंग असंही बंद पडलं मग नाही म्हणजे मला माहिती नाही असंही नेट केलेलं आहे का हॉटेलचा काही इश्यू झाला आहे नेटचा, त्यामुळे तसंही लाईव्ह स्ट्रीमिंग बंद.
नेट बंद ऑडिओ लागणार आहे ऑडिओ लागणार आहे ऑडिओ लागणार आहे
Good evening. Welcome to validatory session. I invite everyone, including Navera ma'am, Nale ma'am, Mane ma'am, and Dharmija ma'am also. Dharmija ma'am, Dharmija ma'am, please come on the dais.
घेऊ का तुम्ही तुला पण येऊ घेते
So students, I know you all are very eager to know the results. It will not take much time, right? We'll soon announce. So to start with, I will start with quote of Malala Yousafzai. She has said, "The value of conferences is not just in what is said, but in the connections made, the collaborations formed, and the ideas sparked." So I'm quite that over these past 2 days, many connections were made, right? At least few ideas sparked amongst all. They were mind-blowing. I guess everybody had a very wonderful time. Do you agree with me? Yes. But then you all know as every beginning has an end. So here we come to validatory session of International Symposium and Conference Synergy 2024. So to start with, I would like to invite our principal, Dr. Manisha Dale ma'am, to come and share a few words along with announcing winners of online as well as offline presentation.
Good afternoon, or I may say now good evening all. So this conference here, our respected Mr. Vishwas Vaidya, Senior Consultant, and Dr. Manoj Jain, present over here, HOD and DC Department. Good evening all. So dignitaries on the dais, Manoj Jain sir, present over here, Mr. Vishwas Vaidya, HOD NTC department, Dr. Mani, coordinator of this conference, Dr. Dhanvijay madam, advisor for this conference or symposium, or I can say driving force behind this conference, Nabega madam, and all the faculty members, staff members, and my dear students present over here. So this is a symposium and startup exhibition. Synergy 2024 is towards the end now. We are in the valedictory function. So, but this has given a lot to you all, or to all of us. Now in that, I can say that our in everybody's mind what I feel after going through the exhaustive sessions from yesterday morning 9 o'clock so till 5 o'clock today. So whatever are the session that has been delivered by the experts from various industries and academia that are really very useful and left a thought in everyone's mind. What I feel is how we can make Industry Institute collaboration active, live, or get maximum out of it. How we can use this platform for this platform in Synergy 24 for internship, apprenticeship, placement, startup, entrepreneurship. Economy, shortly we are going for that also economy. So how we can use this platform for which is the skill developments of the students to make them industry oriented. So for all purpose we have to use this platform. This is not over conference but is now. So we have to take maximum use of it and let us collaborate with the industries for achieving all this. It is not the purpose of only placement, but we have to achieve many things out of this conference. So employability outcomes are expected to be achieved in terms of, but as I said in the yesterday's morning, employability does not mean only that we have to make the students industry ready. It has many aspects and that we have to fulfill through this. So strong industry academia partnership is needed as they are instrumental in advancing every aspects of this one to make upskill the students as well as to have NEP implementation or curriculum implementation. So all the aspects we have to look upon. So with this, what I feel that this outcome should be there, or this outcome will this conference. Now I will congratulate, or I congratulate Department of ENTC, Dr. Mane Madam, the symposium, which is the first of kind organized by Wadia College of Engineering, which is outside the Wadia College of Engineering also, and first time we are having on such big scale Industry Institute interaction also in this symposium. So I congratulate for that for the and Dr. Mane Madam, coordinator, driving force behind this synergy, and program advisor Professor Nabila Masood Madam, organizing committee Dr. K.S. Tiwari and Professor Y.M. Asgar Madam. And I am admiring and congratulating each and every faculty member, staff member of the department who has played their role very crucially to make this conference successful. So I will not take all the names, but yes, they have made this conference a great success, and it has given a for everyone, and they have to keep that thought rolling now so that the required outcome will come out of that. And also I want to congratulate Dr. Tiwari and Badul Madam in comparing what they had done. Why? Because I am here, because in any condition they cannot move from here and take a nap also in such a room. They have to be alert all the time. Jokes apart, but really they have done a very good job. So congratulations one and all. In advance, I will congratulate all the students who had present this conference either online or offline, because participation, what I always feel, is more important than the numbers that come out. So congratulations to all the students, all the speakers, those who were present from industry or academia from yesterday, for their making their time here for the conference, and making themselves available, giving their time, and giving many inputs to all of speakers, those who were present from yesterday. I thank Vaidya sir for being here from last 2 days and making this, giving many inputs to everyone, those who are present here. So thank you, sir, and thank you one and all. Now I think, shall I declare the winners now?
Yalla ma'am, you can come forward as we were hosting the event for last 2 days. So let's end together.
Thank you, ma'am.
Just for reading the.
थोड़ा सेंटर ले इधर
So, the best paper for the offline session, it is backed by. The paper title is Design of Low Power and High Speed Generic Reversible. It is Dr. K.S. Tiwari Madam, Simran Gill. I request Principal MP Daya Madam. Congratulations, team.
आपण एक असं फोटो घेऊ तुम्ही सर्व वर
फोटो नंतर घ्या ना. ठीक आहे. नंतर आपण फोटो नंतर
The second.
तुम्ही इथेच होल्ड करा फक्त होल्ड करा.
Yeah, your one more paper is coming now with the futures. Not that hard.
Okay, and the second best prize, best paper, best paper award goes to the paper title Wirelessly Empower.
होल्ड करा दादा.
Hello. Yes. Now let's move to online session best paper awards. Award goes to paper ID number SYIST 2024-019. Title of paper is Emotional Exhaustion and Motivation of Frontline Service Providers in the Government Service Insurance System. Basis for Managerial Solutions Promoting Employees Welfare by Rowena R. Eno, Master in Public Administration, Politics, University of Philippines, Florina, DPA. So it happens to be an international paper, guys. What goes to Cultural Heritage Preservation through Technology, a comprehensive study by Leo Bentley, Umaira Binte Halim, Department of Economics and Management, Shanghai University, Xi'an, China. So again we have one more international paper. Best papers of online session 1. Now, from session 2, LoRa-based system for energy efficient building lights, guided by our own Professor Pansare sir, Sanket Dharekar, Riddhi Kulkarni, Please give a big round of applause. So sir, you have to wait. Since students are conducting an online mode,
You will get certificate online.
Please close. Please close. Okay, ready?
and second best paper in online mode is line following autonomous drone for crop monitoring by Okay.
Drone.
Yeah. Second, line following autonomous drone for crop monitoring. I guess it is under guidance of Vaishali ma'am. And Dr. And of course, I did not know. Under guidance of Dale ma'am also. So a big congratulations and big
Chinmay Kulkarni and Aditya Thapke, along with the under the guidance of Dr. M.P. Dalai Madam, Principal ATS Vadia College of Engineering, and Dr. Vaishali Kamya Madam.
Thank you.
Thank you everyone.
Just one sentence I want to add. This drone team had come to my residence last week, and I gave them a lot of inputs, and they were very happy. They were able to do it. With me, I even conduct mock interviews. They are highly useful. Thank you.
Okay. एक group
तुम्ही वरती उभे राहा. हा यार.
वरती थांबता का ते थांबतील बरोबर
राहून जातो यांना प्लीज हो बघतो.
All students, those who are winners, those are in offline mode. Vishaka, Yash, Vinit.
सरांच्या लेवल आहे
All the winners.
मॅम थोडं बाहेर येतो बस बस तू थोडा इकडे ओके रेडी स्माइल होल्ड
Thank you.
हम लोग वरती उभे
I'd like to invite our HOD, Dr. Pranoti Mani to share her few takeaways of last 2 days. Good evening, all of you. Good evening. He is there. So please there a few minutes more. Dr. Manoj Jain, Mr. Vishwas Vaidya, Principal Dali ma'am, the coordinator of this conference, which is Dr. Dhanvijay ma'am, program advisor and heart of this conference, Professor Nabega Masood ma'am, all the faculty members, my dear students and all the participants for this conference. I welcome you for the valedictory session of this today's full brainstorming session. I thank all the dignitaries, I thank all the guests, industry experts for sharing their views, which are very valuable for us as we are going for autonomy and we are about to implement the national education policy. Benjamin Franklin rightly said, "Tell me and I forget, teach me and I remember, involve me and I learn." So keeping this in mind, our objective for this conference is to involve industry, people, startup people for this academic institutions to go further. So involvement is very much important, and through these two days, we have observed a lot that this objective has been satisfied. The main objective was to involve these people, involve the industry people, involve the startup, so that we will get the inputs, very valuable inputs, so that as we are going for autonomy and national education policy is also in pipeline for this. So the outcome, what we are expecting through this conference and through the symposium are the exchange of knowledge and best practices, then foster collaboration between industry and academia to achieve the goals of improving curriculum in the direction of NAP, and understanding the challenges and opportunities in education to stimulate further actions in a dialogue with the industries and with the stakeholders. Then startups, they are also playing a major role in this by handholding the students, by involving them, by taking them into their decisions, their actions and all. So to understand the nuances of industries. So keeping this in mind, and I think all we have observed in these 2 days, these objectives and these outcomes, we have satisfied. So we have closed the loop from objectives to outcomes. So I'll not take much of your time. I thank you for patience listening and for attending these 2 days very patiently. I really appreciate the efforts taken by our student volunteers and student participants. Sir, we have here the students not only for paper presentation, but the students are from e-Baha winners, the teams are there. Then Robo Club winners are there, their team is there. And ITSA, we have co-curricular, extracurricular activity clubs. So all these students are there and they are taking very much effort since a month to make this conference successful, along with our faculties. As you can see, our faculties over here, very enthusiastic team is there with me. I am very fortunate. Though everyone is giving credit to the HOD and all, but it's not my credit. Actual credit is faculty of ENTC. These students are witnessed that we are arranging so many events, and these faculties are doing hard work day and night. So no one is asking at 4:20, ma'am, should I leave? They are there
till the task is being completed. So I really appreciate you. We congratulate all the winners, all the participants over here, and a big thank you to all of you present over here. Thank you.
Thank you so much, ma'am. Now I would like to invite Dr. Pranay Kumbhijana, coordinator of this conference, Synergy 2024, to find the proposed vote of thanks. So over to ma'am.
Thank you, ma'am. Of Electronics and Telecommunication Department of Modern Education Society's Vadia College of Engineering, I, Dr. Pranay Kumbhijana, extend my heartfelt gratitude to each of you for Synergy 2024 International Symposium and Conference, which was scheduled on 15th and 16th of April 2024. I would like to express our deepest appreciation to our esteemed speakers, both offline as well as online, for sharing their expertise with us. Their valuable contributions have enriched our understanding in various topics. A special thanks goes to Mr. Vishwas Vaidya, who has for our Synergy 2024. Special thanks to him. May I have a round of applause? I am taking this opportunity for our on the dais esteemed dignitaries, Vishwas Vaidya sir, Dr. Manoj Zesar, Honorable Principal Dr. M.P. Dalema, Dr. P.P. Mane ma'am, HOD, ENTC Department, and our program advisor, the backbone of this event, Professor Yusuf Zayman. Additionally, a special thanks to our sponsors, IET, ICT, which is a knowledge partner, and especially Mr. Prakash Divakaran sir, who is an academic partner of Global Research Conference Forum, without which this event would not have been possible. Thanks to all the startups for devoting their time and setting up their innovations. I am thankful now to our esteemed chief guest, Mr. Bharat Gite sir for the first day, and Mr. Abhijit More for gracing the occasion 2 days. As we reflect on the discussions and presentations from today, the research work from countries like Philippines, China, etc., it is clear that we have gained valuable insights and perspectives that will undoubtedly let us carry forward the spirit of collaboration and innovation that has been characterized this event. Minds. These individuals who bear the responsibility of advancing technical discourse and who will be the serve as a torch bearers for various fields of innovations. I take this opportunity to thank our management, Dr. A.S. Chandak, Trustee, Modern Education Society, and Professor Sachin Sanav sir, for supporting us in all aspects for the success of this event. Our special thanks goes to our CFO, Dr. Ganesan sir, for his guidance and of course to be one of the keynote speakers. I extend my thanks to Honorable Principal Dr. Dalema for her guidance and support. Gratitude gratitude to our Honorable HOD, Dr. Constant advice, invaluable support, and the foresightedness with which she has taken this event in the forefront. Your support means a lot to me, ma'am. And the most important, our program advisor of Synergy 2024, Professor Nabila Yusufzai, who has been instrumental basically in shaping our event by offering valuable insights and met. And most importantly, as Dalima has said, she is actually the driving force of our event. Thank you, ma'am. It's the hard work and dedication of my organizing team, volunteers, and all those who are behind the scenes to ensure everything that runs smoothly, especially the backbone for our event, Dr. K.S. Tiwari ma'am and Professor Yogita Asgar ma'am. Thank you. Efforts put in by Mr. Praveen Rao, our system admin, for facilitating communication logistics. Give my thanks to our technical non-teaching staff as well as the support staff. Akshay from Modern Education Society as well as for their effort. Extend my appreciation to our online team members, evaluated, even reviewed the online papers which were submitted. We are deeply grateful to acknowledge the ambience which is provided by Mr. Bhagwan, the impeccable hospitality and the food which is provided here in Courtyard Marriott. Actually, we have cherished it and we will remember it. The staff's commitment over here to ensure a seamless experience for our guests will not go unnoticed. Special thanks to Mr. Tushar Gadekar sir for his invaluable support in making this event a resounding success and ensuring the smooth execution of. In closing, I extend my sincere thanks once again for your active participation and contributions, to all the paper presenters again, to all the speakers, panelists, the session chairs, judges. We look forward to continued engagement and the future opportunities to convene. And as ma'am has said, Dali ma'am has said, this is just the beginning. We will be having so as to foster the need of today's generation, so as to be in accordance with the industry. Thank you so much. Now I hand over the section to Dr. Tiwari ma'am.
Hello? Yes. So that's the end. Let's disperse now. Formally session is over. It's concluded. Okay. So participated today in offline mode. Their certificates are ready. Don't forget to collect it from Aparna ma'am. Here also you can collect it. She is having with her. So don't forget to collect it. Otherwise, session is over. Formal conclusion takes place. You all can have tea and high tea. Enjoy. Let's have group photograph. we can lead. Thank you so much. Device electronics startup stall is really very exciting. The simulator which they have brought is really very fantastic. Don't forget.
Actually coming right to the footsteps to go and add those designs of HMI. I request all the students as you are leaving the premises, please go to the booth and who has already seen the other.
I request all staff kindly come over here for photograph.